is considerably important in packaging history because of its unique property and widespread use in particularly food sector. The first commercial plastic injection molding machine came into practice in 1926, and it blew lots of application in present era of food packaging. About 1950s, introduction of Tetra Pak has revolutionized aseptic processing. As we all know nowadays, Tetra Pak is widely used for dairy product, beverages, and which can preserve the food products at a room temperature, do not require any refrigeration for a long period of time up to 6 months. The use of polypropylene started in 1954, and this polypropylene has several benefits as a packaging material. Our traditional packaging material, as we all know, because it is inert material and it could not react with the food or beverages, and its durability is also very high. It is resistant to moisture, oil, chemicals, and ensuring long-last application. And at present, if you look at the total market of polypropylene in packaging, it is worth $100 billion US. Then the concept of recycling came into practice in 1970s. Labeling is very important, and it was first realized in 1996. There are regulations was enforced, and packaging regulation came some 2 decades back. And nowadays, as we all know, market is flooded with products having active packaging, intelligent packaging, and smart packaging, because this packaging do offer more benefit over the conventional packaging. So if you look at the packaging, then this packaging could be broadly divided into these 4 categories. Primary packaging material generally comes in direct contact with the product itself, and its main purpose is to protect, preserve, and contain the product. It provides defense against the external factors like moisture, air, and light. The examples include blisters, packs, bottles, cans, tubes, and wrappers. Secondary packaging system, generally it is a layer surrounding the primary packaging and serves to group multiple primary packaging together. So it provides additional benefit of protection during storage and transport and facilitate handling. Example include cardboard boxes, cartoons, shrink wraps, and display boxes. Tertiary packaging used for the bulk handling, storage, and transportation of the food products. It protects primary and secondary packaging during shipping and warehousing, and also facilitates efficient loading and unloading. The examples include corrugated card boxes, pallets, stretched fills, and crates. The quaternary packaging refers to large size container used in global supply chain to transport goods over a long period of time. While less commonly discussed, this particular packaging plays vital role in bulk handling and shipping, particularly in industry involving extensive logistics. You know its examples: large shipping containers and metal crates. Understanding these different levels of packaging is a very crucial for the business to ensure the product quality and safety. Now, coming to the primary packaging material, particularly which I'm focusing for this particular discussions, then this packaging could be represents progression in packaging technology, and each of these types will have different functionalities. Level of interaction with package the product and environment. So there are 4 types. Passive packaging is a conventional packaging. It is the most basic form of packaging, which generally provides benefit of preservation, and containment. It provides inherent protection qualities like barrier against moisture or oxygen without actively interacting with the product or environment. As we've seen its example like plastic bags, cardboard boxes, and glass boxes. 95% of our present food products, we are generally using passive packaging. But from last 1 decade, now momentum has been changed and importance of active and intelligent packaging also has been realized. So second category of this active packaging, generally this is the packaging system which reacts with the stimuli, and it interacting with the product and environment. So preservation of the product could be enhanced. Active packaging could be either it could be used various active agents which will either remove oxygen, moisture, or it can facilitate antimicrobial agents which will ultimately extend the shelf life and maintain the product quality. The third type of packaging system is intelligent packaging system, where this packaging incorporates various sensors, and that will help to monitor the product information about the freshness, ripeness, temperature it exposed during the processing to the until it reached to the consumer. So examples include time temperature indicator, freshness and ripeness indicator, which will alert the consumer about the potential spoilage. So smart packaging system is the fourth category of packaging system evolved recently, which will use this active packaging and intelligent packaging along with the chemical engineering, electronic engineering, electrical engineering, and bioengineering science. So this kind of technology offers the better benefit to the consumer about the quality and safety of the products, about the convenience of the product, and about the tracking of the products. Examples are QR code, RFID tags, and digital identifiers which track the product and provide information about the product to the consumer. So now we'll look at the smart packaging system. As I will explain, that smart packaging system works beyond the conventional containment and protection functions. It will many more functional benefit over the conventional packaging system, which will help to maintain quality, safety, and sensory attributes of foods, along with allow us to monitor, sense, track, and interacting with the product, supply chain, and consumer. So if you look at this smart packaging, then it do have two important components. One is active packaging, which interact with the product or environment to extend the shelf life, and intelligent packaging, which will monitor the condition of packaged product or environment and provide useful information. So you can see here, protection and preservation is the main function of the conventional packaging, while active packaging is facilitating many more functions. So it incorporates certain active agents, so that active agents can react with the environment and make environment suitable, so shelf life of the product could be extended. While intelligent packaging will also provide communication and information about the product right from procurement to it until it reaches to the consumer. So why should one should go for the smart packaging? Then smart packaging, as I've said, incorporates many functionalities beside protection and preservation, it will have better applications. If you look at the importance of smart packaging system, then this particular system provides or assure better way the quality and convenience to the consumer. At present, it is the era of e-commerce growth and globalization, so which also require traceability and security of the shipment. Present food safety regulation could also be enabled by using smart packaging systems, and this system also better way assure the safety and quality. Besides this, it also prevent the frauds, adulteration, and particularly inform about the geographical location of the foods. Coming to the active packaging system, which is very important component of the smart packaging system. The active packaging system generally reacts with the environment in a positive way to enhance the shelf life of the product, to preserve the sensory attribute of the products, and also to ensure the quality of the products. So if you look at the core function of the active packaging, then active packaging eliminates unwanted compound. As you all know, oxygen, if present in the surrounding environment, then that would lead to support the growth of microorganism, oxidation of various important nutrients. So it has to be eliminated. So there are some active agents present in active packaging system which ensure elimination of oxygen. Same way ethylene produced by fruits. Fruits and vegetable is a category of food product which is respiring in the packaging system. And when it gets ripened, ethylene will produce. So if you want to delay this ripening process to extend the shelf life, then it requires elimination of ethylene. So these particular active agents present in packaging system eliminates oxygen and ethylene. It may eliminate or include carbon dioxide as per the need. It may prevent microbial growth, or it may change the physical condition of the packaging environment in such a way that favor the shelf life and quality maintenance of the product. You can see here the packaging material do consist of certain active agents which may release inside the packaging environment. For example, there are agents which release carbon dioxide, they may release antioxidant, ethylene, antimicrobials, flavors, ethanol, and preservative in order to give better shelf life. Besides this, there are certain active agents may also be incorporated in the active packaging which may remove or eliminate unwanted stimuli such as carbon dioxide, oxygen, ethylene, odor, and moisture. So we'll see one by one various functionalities of this active packaging system. You can see here, there are active packaging which incorporates oxygen scavengers or oxygen removals. So this kind of active agents are widely used in a meat industries and oil industries where rancidity is a problem due to the presence of oxygen. Then second type of active agents are ethylene scavengers. As I have said, that ripening of the fruit could be delayed, then shelf life could be extended. So various agents like potassium permanganate, metal oxides, activated carbon may be used in a packaging system to remove the ethylene, and that could delay the ripening process and shelf life could be extended. Certain antimicrobial agents already we used to incorporate as a food additive in the food products. But nowadays, this packaging system could also incorporate this kind of antimicrobial agents, and they release to the environment as and when needed to ensure better shelf life. Same way, carbon dioxide do have both role. In certain foods, presence of carbon dioxide is negative, while certain food demand carbon dioxide like meat and meat products. So both types of active agents available which will release carbon dioxide or which can absorb carbon dioxide during the storage through packaging system. Besides these, antioxidants may also be incorporated in packaging system, which will ensure better shelf life of the products. So now we'll see one by one these active agents we use in active packaging. First is oxygen scavengers. We all know removal of oxygen is very important because it may lead to oxidation of fats, which is responsible for rancidity of fried product. It may lead to browning in meat and fading of pigment. Presence of oxygen may also support growth of bacteria and mold. And this particular oxygen may also lead to oxidation of some of the bioactive compounds like vitamins. They may also degrade the flavor compounds. And that's why it becomes very necessary to maintain the quality of product to product, that the product should be free of oxygen. So this removing of oxygen could extend the shelf life and have a better quality. So there are certain active agents available which will chemically react with oxygen present in packaging systems, atmosphere, and forming a stable non-reactive compound such as iron oxide, dihydroascorbic acid, gluconic acid, likewise. So I will discuss about 4 different types of oxygen scavengers. The most widely used one is the iron-based oxygen scavenger. You might have seen many of the food products do have a sachet filled with the iron. This iron powder, because in a powder form, iron do have a more surface area and it can efficiently react with oxygen and will remove it. So iron powder react with oxygen and moisture and convert it into iron oxide. So it reduces oxygen from aspect of packaging up to a level of 0.01%. So if we use vacuum packaging or gas flush packaging, nitrogen packaging, then in that packaging also about 0.1 to 0.5% oxygen is present. But if you do have this kind of iron-based oxygen scavengers, then it can reduce completely oxygen from the environment. So it does several advantages like highly effective, fast-acting, and works in modified atmosphere packaging. So it does wide applications from such as used in dried meats, bakery items, nuts, seeds, powdered foods, and pet foods. One of the disadvantage of these iron-based oxygen scavengers that if this particular food products, when you have this kind of scavengers, they cannot pass through metal detector line. And they may also corrode the equipment because iron is an oxidative agent. So these are various commercial products widely used in a form of sachets to remove oxygen from the food products. The second oxygen scavenger is ascorbic acid based. This ascorbic acid reacts with oxygen and producing dihydroascorbic acid and water. This is colorless. Said it could be used in transparent or oil-linked packaging. So previous one, sachet form of the oxygen scavenger is widely used for the solid foods, but here ascorbic based scavengers could also be used for liquid food formulation like beverages. It is transparent or flexible. It can also be used in infant formula powder and also used in organic foods. Various commercial product is already available in a developed world. The third important oxygen scavenger category is enzyme based. As you all know, widely used enzyme in food preservation is the glucose oxidase. This particular enzyme oxidizes the glucose into gluconic acid and hydrogen peroxide, so it will remove the oxygen from the atmosphere. So it is widely in dry food, said as it is food grade, and there is no metallic residues. It do a wide application in confectionery, powdered dairy, NutriCare products, and ready meals with controlled moisture. Bioca Limited of Finland is pioneer in providing this kind of enzyme-based commercial products. The fourth important category of oxygen scavenger is polymer or film integrated scavengers. So here, these compounds are embedded into the plastic layer, may be embedded into PET or multi-layer films, and slowly react with the oxygen. So there is no requirement of any sachet. It maintains oxygen barrier even after pinholes, and ideal for better bottles and pouches. So if the wide application in juice bottles, dairy packaging, baby food pouches, and alcohol sensitive beverages. One of the limitation of all these, one of the limitation of this polymer film integrated scavenger is that before it is filled, it should be protected from oxygen. Otherwise, whatever the active agents, they may get saturated and it may not work. The second important category of active agent is used in active packaging is carbon dioxide emitters or absorber. As I have said, carbon dioxide play a key role in internal environment of food packaging because it has positive as well as negative effect. If you look at the positive role, then it inhibits the growth of microorganisms and thus extend the shelf life and also ensure the safety. It reduces the respiration rate and thus it extend the shelf life of the product and work synergistically with the oxygen in MAP. You can also use in combination of oxygen scavengers with this carbon dioxide absorbers. Negative effect: if excess of carbon dioxide is present, then that may cause package swelling, especially in cheese and meat industries. It alters flavor, aroma, and textures, increase package pressure, leading to leaks and rot, condense to form carbonic acid, which lowers pH and affect product quality. These carbon dioxide emitters are devices or pads or films that generate carbon dioxide inside the package to enhance the antimicrobial protection and modify the internal atmosphere. So they generally react with acid plus carbonate and release the carbon dioxide. One of the example is sodium bicarbonate. When react with citric acid in presence of moisture, then carbon dioxide will generate. It is widely used in meat packaging, where meat pads will release this kind of carbon dioxide, and that could provide whatever the need of respiration and extend the shelf life. So if the wide application in meat and seafood, bread and bakery items, and even poultry packaging. This kind of carbon dioxide emitter is available in several formats, like pads, maybe in a film layers, or it could be even integrated in the sachet. So depending upon the application, this format could be used, and it enables the packaging system to inhibit spoilage from bacteria and molds and maintain the color of meats and ultimately enhance the shelf life of the product. The carbon dioxide absorbers generally are the material or sachets that remove excess of carbon dioxide from the sealed pen. There are two types of absorbers. One is chemical absorbers. These are the chemical compounds like calcium hydroxide, sodium hydroxide, or magnesium hydroxide that react with carbon dioxide present in the environment and convert it into the stable carbonates. While there are certain physical absorbers available which could be used as a packaging material like activated carbon, or it could be even impregnated on the packaging material. So examples are activated carbon, zeolites, and porous polymer, which will able to absorb the carbon dioxide. So here you can see these carbon dioxide absorbers also available in a form of sachets or maybe in a form of labels or integrated films, and they prevent swelling or blotting of the package, maintain the flavor and texture of the product, and control internal pH. So type of oxygen absorbent to be used will be decided, or carbon dioxide absorbent to be used is decided upon the type of food, water activity of food, amount of dissolved oxygens present in the food, desired shelf life of the product, and oxygen probability of this particular packaging system. The third category of active agent used in active packaging system are the antimicrobials. Antimicrobial packaging, antimicrobial packaging refers to packaging material incorporated with agents that inhibit the growth of spoilage and pathogenic forming microorganisms on the food surfaces. So these are the general antimicrobials which may be impregnated or may be incorporated in a matrix of the packaging system that ensure the protection from the microorganism which otherwise spoil it or which otherwise responsible for the infections. So ultimately it ensures the food safety and extend the shelf life. So there are two basic mechanisms of antimicrobial based food packaging systems. Migratory based system, where the packaging system, through packaging system, antimicrobials may migrate inside the food and ensure the safety concern, while non-migratory contact active systems do possess the antimicrobial agents embedded over the surface and ensure the safety from the microorganism. So as you all know, there are several types of antimicrobials available in the market. All of this kind of available antimicrobials nowadays could be used as active agents for antimicrobial packaging. In various formats they are available. It may be as edible coating films, or may be embedded in polymers, maybe edible films or spray or dips or antimicrobial pads. Most widely used are edible coating and edible coating films with the nanoparticles, particularly silver nanoparticles, and essential oils. So these are the commercial products available which ensure particularly protection of the food from entry of spoilage organism as well as the pathogens. The fourth kind of active agents used in active packaging is the moisture absorber. These moisture absorbers are also known as desiccants or humidity scavengers, which absorb excess of moisture. As you all know, water activity is very important in shelf life. If you could want to extend the shelf life, then one must have to ensure that water activity should be minimum. So this kind of moisture absorbers protect the product from the water and prevent microbial growth, maintain the texture of the product, prevent clumping of the product, inhibit chemical degradation, and control the condensation. These are also available in almost all kind of formats and used in a wide variety of the products. The most widely used moisture absorbing material is the silica gel and calcium carbonate. Besides this, calcium oxide could also be used, which is irreversibly bind with the water and convert it into calcium hydroxides. These are the commercial products which is widely used to ensure the removal of moisture from the environment surrounding the foods, and that's why it ensures the better shelf life. If you look at the advanced technologies used in moisture absorbance, then breathable films available. So these breathable films allows moisture vapor to escape while block the oxygen. So it is permeable. It allows selective permeability, so it will not allow entry of oxygen but release the moisture from the film. Same way, multifunctional pads are also available, which you have many different types of active agents. So besides removing moisture, it also takes care of odor, carbon dioxide, or oxygen altogether. There are intelligent desiccants available, which can also give signaling by changing the color upon saturation. So real-time monitoring of the quality could also be possible. Then biodegradable absorbers available, which is made up from biodegradable materials, and certain absorbers which is available in a form of ink. So you have to just use in a form of printing. So that printing ink will take care of the moisture of the product. The fifth category of active agent used in active packaging is antioxidant. As you all know, antioxidant is very important additive in any food products because this will take care of the free radical and scavenging oxygens. So there are antioxidant packagings systems available which incorporate this kind of antioxidant agents, which will actively prevent or delay oxidative deterioration, and thus it will protect the product from lipid rancidity, color fading, nutrient degradation, and even loss of aroma. If you look at the working principle of this kind of antioxidants, then there are two different mechanisms. Scavenging free radical, where antioxidants donate electron to free radicals and stabilize them and halting the chain reaction. While second category of the antioxidant packaging system, where it will prevent or delay the oxidation by binding with the pro-oxidant metal, reduce the oxygen concentration and quenching the signal oxygen. This antioxidant can be released into the food or ad space, or it may be immobilized in the packaging system. You can see here there are 4 different types of packaging system where antioxidants are incorporated. In type coating an active layer to the packaging system, while in a figure B, you can see it is incorporated as an active agent, incorporation of active agent as a polymer matrix. While type C is a multi-layer active film, and type D, where antioxidants are covalently immobilized over the packaging system. So almost all type of antioxidants we use as an additive could nowadays incorporated into packaging systems, and packaging systems will release them as per the need to ensure the product quality. Wide variety of formats available. The sixth category of active agents are ethylene scavengers. As I've discussed earlier, that fruits and vegetables particularly are under respiration when they are packaged, and when they get ripened, ethylene will be released. So if you want to delay the ripening, then you have to remove this ethylene from the surrounding environment. So this kind of ethylene scavengers are active agents which are designed to absorb or neutralize ethylene gas inside the package and storage environment to protect the food products from rapid ripening, leafy vegetables from loss of its visual color, then to maintain the texture, because if ethylene would be there in the environment, then firmness would be lost from the fruits and vegetables. It may also ensure preservation of the vitamins. So controlling the ethylene levels help us to extend the shelf life, maintaining the sensory properties of the foods and prevent the food from spoilage. So these are the various ethylene scavengers available for different applications, particularly for fruits and vegetable preservations. If you look at the active agent used as ethylene scavengers in packaging material, then KMNO4 is widely used, which will oxidize ethylene into carbon dioxide and water. But one of the limitations of KMNO4 is it is toxic in nature. So instead of that, one can also go for activated carbon or zeolite, which absorb ethylene gas on porous surface, or even one can go for titanium dioxide, which catalyze ethylene breakdown under UV. There are enzymatic scavengers also available, and nanomaterial based ethylene scavengers are also available in market. So these are the commercial products which are available in the market to remove ethylene from the environment surrounding the food packaging system. The next category of active agent is flavor and odor absorbers. So here there are again two possible ways. There are many food products where you require addition of flavors, and there are many food products where you have to require removal of the bad odors. So both kind of active agents available which can remove or add desired flavor or odor. The flavor and odor absorbers are integrated in the food packaging systems that remove or neutralize undesirable odor, prevent flavor cross-contamination, and maintain original sensory quality of the product. They absorb volatile organic compound which is responsible for the flavors like aldehyde, ketone, sulfur. They scavenge this kind of compound, or they prevent building up of this kind of compound during storage, transport, and retail display. So these are the various active agents used to mask the flavor or odor. Activated carbon is used to absorb wide range of volatile organic compounds. Then silica gel could also be used to absorb moisture and some organic compounds. The next active agent, where we will discuss group of active agents, which is very convenient in a present day packaging system. So first one is self-heating packaging system. Now, there are certain situations. If someone go on vacation on the hilly area or mountain where very cold, and if you want some warm drink, then under that particular situation in a remote place, this kind of self-heating packaging system is very useful and convenient. So it its own content via internal exothermic reactions. So it do have active agents when it will release, then they release the heat. So it do have multi-chamber designed vessel, typically a food pouch or having a chemical reactants, and opening upon this particular pouch or cans will activate the agents, and that will undergo a reaction and generate the heat, and that may lead to warming up of the food products. So, particularly lime and water is widely used for self-heating packaging system. So when calcium oxide mixed with the water, it generates the heat, and it will heat up the product up to 80 degrees. So US military launches this kind of self-heating coffee cans, which can heat the product in a 3 minute up to a 45-degree temperature. Same way, if you are in a remote place and you want the product should be particularly beverages, it should be chilled down within when it has to be used. So this kind of self-cooling packaging systems also available, where active agents are undergo reaction, and it will endothermic reaction, and it will lead to cooling. So it cools down the beverages without refrigeration. So it is endothermic reaction. Particular example is ammonium nitrate with water. Then temperature will reduce up to 10 to 15 degrees within a minute. So gas expansion, cooling, particularly SFC triggered, chill down the cans. So this is very convenient packaging systems. The third convenient packaging system where active packaging is important is self-venting packaging systems. This is widely used in microwavable foods. So it do not require any puncturing at the time of microwave. So that enables the steam to release without any puncturing. So films or tray leads with pressure activated vents, pre-perforated with vents for pre-perforation or heat-sensitive valves that open up during microwave application and release the steam, ensuring the safety and prevent the bursting. So MTR food and even Haldiram has this kind of self-venting bags and microwavable active packaging systems available for idli, upma, and noodles. The fourth category of convenient active packaging system is subceptors for microwave. As you all know, in microwave cooking, generally the waves react with the water, and it will lead to heating up the product. Here, whatever the packaging system you can see here, the inside of the packaging material is coated with the aluminum or carbon. So when it will undergo microwave application, then this aluminum and carbon coating inside absorb this kind of energy, and that radiates the heat, which will mimic the browning and crisping of the food. So this kind of products are ready to use. When upon microwave application, it will give a better sensory attributes to the product beside heating. So microwave popcorn bags, hot package crisping sleeves, and frozen meal expecting a crispy finish are available in this kind of packaging system. The next convenient active packaging system is nitrogen charged widgets. These widgets are a device are very useful for particular job. So it is useful for some beverages where particularly stouts and porters. So when you open up this kind of widgets, then it will charge with the nitrogen. It will release the nitrogen because it was charged with the nitrogen during filling process. So when you open it up, the nitrogen will be released, and this will releases nitrogen bubble, creating a creamy texture and unique aspects to a nitro tap. Even in stout, this kind of packaging is very important. Then certain emerging and experimental active concepts where we have ethanol emitters. So there are active agents available which will release the ethanol into environment, which will act as antimicrobials. So particularly in Japan, bakery and baking products, this kind of ethanol emitters available. Then flavor emitters, as I have said, that flavors are many times need at the time of application. So active agents, when you open up the beverage or can, then it may release the aroma or flavor compound. Then pesticide emitters also take care of residual pesticide from the product. And battery-free active release systems where NFC cells are used that control release of antioxidant or antimicrobial compound in response to spoilage. Now coming to the second important category of intelligent category of packaging system, that is intelligent packaging. Intelligent packaging system are advanced packaging systems designed to sense, monitor, and sometimes communicate information about the condition of real-time condition of the product or its surrounding environment to the consumer. So beside preservation, safety, quality assurance, this kind of packaging system could offer extra functionalities like tracking, detecting, signaling, indicating tampering, and helping ensuring the safety and quality of the product. So we'll now discuss different types of intelligent packaging systems available and its application. So there are basically three primary purposes of intelligent packaging. The first purpose, intelligent packaging system provide real-time monitoring of the quality of product, like whether product is fresh or ripened. Also, it ensures its traceability. The second objective is the convenience of the consumer. So when this packaging system is there, then it enhances the knowledge about the product to the consumer. It is the application and reduce the waste. And the third important purpose of the intelligent packaging system is it protect against the theft and counterfeiting. So whatever the authenticity of the product, geographical location of the product, the logistic, whether product has been tampered throughout the supply chain, each and every information could be available by this kind of intelligent packaging system. So we'll see few of these important intelligent packaging system prevailing in market. They may be prevail in a form of quality indicators, or maybe in a form of sensors, or maybe in a form of chips. We'll first go through quality indicators. Freshness indicators. There are thermochromic inks available. This kind of inks will act as a agent to indicate the freshness of the products. So freshness indicators are mechanisms within a packaging system that visually or electronically report real-time quality of the product, particularly perishable product. So this kind of products provide indication about the chemical changes in the package headspace that ultimately correlated with the spoilage. These changes may be either change in the pH of the product, accumulation of volatile amines or carbon dioxide or sulfide, ethylene or rightness gases. So ultimately, if this kind of changes occur, then this kind of agents will undergo color change and they may show the real-time status of the product throughout the preservation. The second category of intelligent packaging system is ripeness indicator, where you can come to know about the ripeness of the product. You can see here the fruits. These particularly indicators are available in a form of sticker. So these particularly indicators designed in such a way that change in color as aromatic volatiles are accumulated during the ripening process. One of the most commercially used ripeness indicator is ripe sense. The color will change, changing the spot label indicative to ripening gases on the fruit like mangoes, kiwis, and pears. The third intelligent packaging where indicators are used is the gas responsive indicator. So it will monitor specific spoilage due to gases like carbon dioxide, sulfide, or biogenic amines. So this kind of gases, when accumulates, then it will react with these particular indicators and change the color. And change in the color will inform the consumer about the quality of product. The second category beside indicators is the time temperature indicator as an intelligent packaging. So these TTI are small visual labels or device attached to the packaging that provides cumulative record of temperature exposure over a time. So there are three different types of time temperature indicators that is prevalent in the present market. The first one is the critical temperature indicators, which shows whether a specific temperature threshold has been exceeded during the storage. And when it gets exceeded, then thermochromic ink will irreversibly change the color, and that will indicate that particular product is exposed to the threshold limit of the temperature for that particular product. So whether your product has been exposed to a very high temperature or not during the supply chain could be monitored. The second TTI based intelligent packaging system were critical time temperature indicators. So this kind of indicators respond when both time and temperature threshold are exceeded. So whether your product has been exposed to a particular temperature for a particular time of period could also monitored through this TTI. So when your particular product will reach to a threshold temperature for a set period of time, then color will change and it will indicate that your product has been exposed to threshold limit of temperature and time, and this will change the color so you can predict the quality of the product. And the third type of time temperature indicator, which is a real-time tracking mechanism where whatever the product being exposed throughout the supply chain, this will give information about the temperature attained during the storage in entire supply chain. So diffusion-based enzymatic polymerization of microbial growth causing gradual visual change could be widely used. You can see here phase 1, phase 2, phase 3, whether it has attained more than 10 degree or not, that you can monitor. So these are some of the commercial time temperature based indicators used as an intelligent packaging system. Then next is the integrity indicators. These integrity indicators, also called leak indicators, give information about the leaches or permeability changes or some tempering. So they help signal package compromise, such a seal failure or container damage that can lead to spoilage or microbial contamination. This is a critical in packaging packaged modified atmosphere or perishable food. There are several types of integrity indicators available that could be either oxygen or CO2 based colorimetric indicator, chemical leak sensors, printed electronic leak sensors, sensor enabled data carriers, image based visual inspection systems. All of these type of integrity indicators, based on these principles, several packaging systems are available in market. Due to lack of time, I could not able to give elaborate discussion of this kind of each of the types, but we'll go through some of the important intelligent packaging system. So second to indicators are the sensors. There are sensor-based intelligent packaging systems. These include gas sensors. These gas sensors are device or material that detect and measure specific gases in the surrounding environment, such as presence of carbon dioxide, ethylene, or ammonia. The first type of gas sensor is the oxygen sensors. You can see here packaging material where oxygen sensors are available in a form of sticker. So this type of gas sensors specifically detect oxygen levels inside the package environment. They are used to ensure oxygen sensitive product remain in a low oxygen environment and ensure modified atmospheric packaging or vacuum sealing is intact, and that oxidation or microbial growth risk could be minimized. So here, when it is active, you can see this particular packaging sticker is green, while as it is exposed to oxygen, it becomes orange. Then same way, carbon dioxide sensors also available. There are two types of carbon dioxide sensor. This is non-dispersive integrated sensors or maybe a chemical sensors. They are widely used in modified atmospheric packaging. Enable quality assurance by monitoring real-time carbon dioxide levels within the packaging environment. The third one is ethylene and amine sensors. As we already discussed, ethylene and amine both are negatively affect the product quality in surrounding environment. So whether they are present in surrounding environment could also be monitored through this kind of sensors, which will based on which will particularly reacting with this kind of stimuli. Then many type of intelligent packaging system do also have sensors impregnated or embedded in the packaging systems, which are either made up of biological elements like enzyme, antibodies, aptamer, or even nowadays Phage cocktail could be widely used. So that kind of biosensors, when react with transducer, it will give signaling that could be recorded by data collector, and then processor will process the signal. So these are the various type of biosensors: electrochemical biosensors, optical colorimetric and photometric biosensors, then MIP based biosensor, ENOS and tons of acoustic and gravimetric biosensors. So based on each of these principles, several different types of biosensors available, which will sense the information about the quality, about the safety of the product and convey it to the consumer. Here I will give one of the important example of the biosensor based biosensor, which is antibody based calorimetric biosensor, which is used to detect certain pathogens present in the food, such as Salmonella, E. coli, Listeria, or Campylobacter. Whenever this kind of pathogens come into the environment, it will generate a fluorescent signal visible on the plastic surface. So this will ensure the safety of the food product. Same way, chemical sensors, various type of chemical sensors also available. This may be colorimetric or fluorescence sensor, or conducting polymer or nanochemical sensors, or electrochemical sensors, or metal oxide based sensors that may detect gases, volatile compound, or contaminant and monitor the quality, spoilage, and leakage and safety of the product. Besides these indicator sensors, the one of next category of intelligent packaging is RFID, that is radio frequency identification. So beside barcode, this RFID is now more prevalent in the food packaging system because it will provide information about the product throughout the supply chain. So these are generally RFID, generally made up of three components. It do have text, which is a microchip with an antenna. It do have reader, and then it do have database. Recorder. So this RFID generally, these particularly tags are either they do have their own energy, or they can work on a passive energy, while reader. So this tags will dependent for passive energy for the readers. Readers provide either energy to the tags. So tags will, through its antenna, receive that energy. Readers, when provide the energy, then it will also maintain and synchronize the clock of the data present in microchips, and then whatever the data present in the tags will be transferred to the reader, and reader will convert it into the data through processor. So this is unlike barcode. RFID works without line of sight and enables automated scanning and data writing, offering real-time information and traceability about the product throughout the supply chain or in a logistics. So there are different types of RFID which could be used in packaging system. It could be a passive, where whatever the tags do not have its own energy, it is dependent to the reader. While in active RFID, where the chips do have its own energy. So this RFID have various applications in food industries. It ensures traceability and supply chain visibility. It ensures integration, sensor integration for quality monitoring. It ensures food safety indicators, and also support the e-commerce and supply chain management. Now, coming to the end of this particular session, we have seen that smart packaging offers us many functionalities over its traditional application of packaging system for preservation and containment. But there is also this particular segment of market in a country like India is less than 5% of the products. It is more prevalent in the developed world, but in India, this kind of packaging system has just started some decade ago. This is because it required extra cost. Many times it could be possible that whatever the active agents that we used in packaging system may be passed to the consumer. Many a time, whatever the real-time indication or the indications by the intelligent packaging may not be reliable. And if this kind of passive migration of the active agents into food happens, then there would be some food safety and regulatory issues. And there is also related to recycling features and environment regulation. So these are the few of the factors. Because of that, this smart packaging is not that much popular. Otherwise, if you look at overall, these particular packaging systems is a futuristic concept which ensure the food quality, food safety. It provides convenience to the consumer. Also, it provides to the consumer for the business people, because it enhances the enable to branding of that product. It reduces the waste and also optimize their supply chain. And because of sustainability of this kind of food packaging system, it is also very good for the overall global population. So the future of this smart packaging lies in combining multiple active and intelligent functions into unified systems using printed electronics, IoT connectivity, and AI-driven analytics. There is a substantial need to work on the cost and technology validation. So more trust of the consumer, more trust of the industry people build up, and this kind of technology may prevalent more, so we can assure the better shelf life with a good product quality. So with this, I end this session, and now session is open for questions.
Dear participants, the floor is now open for the queries and questions. Please type your question in the chat box or raise your hand to interact directly with the speaker.
So one question is there in the chat box, that is all these packing systems get activated when comes in contact with atmospheric oxygen, like self-heating and self-cooling, by Srilata Nair ma'am.
Hello.
Yes, sir.
Sir,
Yeah. What is the question?
That all these packing systems gets activated when comes in contact with atmospheric oxygen, like self-heating or self-cooling.
Yeah, in particularly these three different types of active packaging systems I've explained. First one is the oxygen scavengers. So oxygen scavengers, generally where oxygens come into the surrounding environment of the food products, then this kind of active agents present in the packaging system will interact with the oxygen and it will remove it. Same way, in a convenient active packaging system, self-heating and self-cooling can is available. So that is for the convenience of the consumer. So when a person want a warming up of their food products at the time of application, and at that time when you open the can, then that particular opening of the can is linked with the release of these active agents like lime and water. So there are two compartments. In one compartment, lime is filled in the container, and in second compartment there is a water. So when you open up the can, then the barrier between these two compartments will also be opened up, and water will mix with the lime, and it will instantly generate the heat surrounding jacketing in the cans, so your product will get warmer. Same way, in case of the cooling cans, when you open up these cans, then this ammonium nitrate and water, that will mix it up, and it will endothermic reaction generating the low temperature, and your product may get cooled within a few minutes or seconds. So this kind of beauty of this kind of active agent is that whenever particular stimuli in the environment appears, then this kind of active agents will respond to that stimuli, and it will take care of this kind of stimuli, maybe a carbon dioxide, or maybe a ethylene, or maybe a moisture. Until and unless they are not there in the environment, they will remain stable with the packaging system.
Thank you so much, sir. The next question is, sir, that Mamta Sharma ma'am has asked, what if spores are present in packaged food?
What are the?
What if spores are present in packaged food? That means microbiological spores or some other type of the spores are present.
Yes.
Not properly sterilized. That means, I think so. Mamta ma'am, if you are there, you can please unmute yourself and ask the question.
Okay, good evening, sir. It is regarding that sometimes in canned food, we used to come across that if spores are present in that food, they can germinate later and can cause the spoilage. So what type of chemicals or other things we can use, because spores are resistant to acid or some chemical or heat even. So what is the guarantee or assurity that the spores will not be present, or if they are present, then what is the methods or what the consumer can do further?
So in general sense, to remove this kind of microorganism, to enhance the preservation, there are different category of techniques available. We generally widely use is the thermal processing. So in thermal processing, you have 12D concept. When you set the time temperature of your retort, you ensure that your product should have complete elimination of probable organism. Now, by chance, if this kind of organism may remain during thermal treatment, then definitely it will lead to deterioration of your product. So in that case, in that sense, we do have intelligent packaging system. So whenever you have this kind of intelligent packaging system, and by chance if this kind of pathogens or maybe a spoilage forming organism will remain in the product after thermal treatment, then this kind of intelligent system will tell you that now this population of this organism has built up, so it is not suitable for consumption. I have discussed about the sensor-based, biosensor-based intelligent packaging system, where antigen or even a fast cocktail could be used. So whenever this kind of active agents are impregnated on the surface and it comes in contact with any viable cells, it will give signaling, and that information could be used by consumer that will predict the quality of the product.
Dr. Loknath Deshmukh, sir, you want to ask some question? You have raised hand. Please proceed. Dr. Loknath Deshmukh.
Thank you so much, ma'am. That is audible, ma'am?
Yes, yes.
Yes.
Yeah, sir. So I just want to acknowledge for the session, sir. It's very informative. and thank you for your experience that you are sharing here. I have just we can say, I can say it's very layman question that
Yes, yes.
multiple elements you mentioned there, sir. It's very
Yeah,
informative for me personally
yeah,
regarding some to reduce the negative point and to add on some good points. Sir, regarding the carbon emitters
yeah.
जो आपने mention किया.
Uh,
So can we say, sir, that somehow we are adopting or we are having carbonated food material if we are choosing the packed material?
yeah.
So can we say that we are going towards the carbonated? Because generally carbonated word is we are hearing that with uh, drinks, carbonated drinks. But
Particularly, yeah, yeah, yeah. Loknathji,
yeah,
particularly meat and meat products. Meat is under respiration. So they
okay,
require carbon dioxide for better shelf life. So there are carbon dioxide emitting pads available in the packaging systems. So these pads will maintain the carbon dioxide level inside the package system in such a way that meat will remain in respiration state and you can preserve it and stay there. Yeah. Yes.
okay, okay. Thank you so much, sir. Thank you, thank you.
Yeah.
Any more questions? If the participants want to ask any question.
Ma'am, I
Ma'am,
want to
only?
ask something.
Yes, Lenin VR, please.
Yes. Sir, very informative sessions are like, it's wonderful. We are working in dried products, you told about some advanced technologies in moisture absorption. So could you throw a little bit light on that intelligent desiccants? Sir, you have mentioned actually several desiccants and commercial products in selected term like intelligent desiccant, like color changing upon the saturation. Can you throw some commercial products names or something like that, sir, so that I can try?
Yeah, I lost my internet connectivity. Okay. Could you repeat, please, question?
Yes, sir. Advanced technologies in moisture absorption. You have mentioned about like intelligent desiccants. So upon saturation, it color changes irrespective of that moisture content available in the product. So could you throw some actually commercial product names related to that, sir?
Yeah, I already mentioned, I think, so far as moisture absorbers are concerned.
Specifically in that particular, like it missed out actually.
Yeah, so there are several natural clay-based sachets available, which is widely used in snacks. It is
Okay.
Clariant's Decipac commercial brand name. So I can
Okay.
share the whole PPT. You can use
Sure,
this.
sir. Yes, please, sir. Thank you. Thank you so much, sir.
I think.
Yeah. Very informative, sir. Thank you so much for your presentation,
Yeah.
sir.
Because right from the moisture absorbers in all segment of category of food products, this kind of moisture absorbers are very important and crucial, and they
Yes,
are
sir.
available. So commercial products are also available at present.
Thank you, sir. Thank you so much, sir.
Any more question?
If someone wants to ask the question, we can take one more question. Thank you so much, sir, for your so informative session.
Come, ma'am.
Your presentation beautifully highlighted the journey of packaging from passive systems to the new era of active and intelligent packaging. The way you explained innovations such as oxygen scavengers, antimicrobial films, freshness indicators, and RFID-based traceability that has given our participants a clear perspective on how packaging ensures food safety, quality, and sustainability. And your emphasis on the future of smart packaging, its role in reducing food waste, enhancing consumer trust, and integrating IoT and AI was truly inspiring. We sincerely thank you for sharing your expertise and enriching us with knowledge that bridges research and practical application. I am confident that the insights gained today will encourage our participants to explore and apply these innovative technologies in their own fields of work. On behalf of Swami Shri Swarupanand Saraswati Mahavidyalaya and the entire FDP team, I express deep sense of gratitude to you, sir,
Thank you, ma'am.
for your highly insightful and thought-provoking lecture on smart packaging systems. Sir, 1 minute, I want to introduce our next speaker also, Satish Ambati, sir, so that he can also open his video. We can have both the resource person on our screens and take a screenshot of. Thank you so much, sir. I request Dr. Hansa Shukla ma'am also to please open his video so that we can have a picture of our principal ma'am and both the resource person. Thank you so much, ma'am.
Thank you very much for your invitation and providing this opportunity to
Wait for 1 minute, sir, because I want to have a good picture of all the resource person along with the principal ma'am. Principal ma'am, please. Thank you so much, sir.
Thank you, Dr. Bhavesh ji. It's a wonderful session of yours, and then really enjoyed it.
Yeah, thank you, sir. Welcome. So thank you very much, ma'am. Shall I leave now?
Thank you so much, sir, for being with us this evening and making it a wonderful time for smart packaging system. Few more questions were there. I will be asking you personally.
Yeah. Even you can share my contact number.
PPT, yes.
To all the participants.
And thanks to Gaurav Shah, sir, also for introducing you for this platform, and Deshmukh, sir, who let us know about you. And from Anand University, Agriculture University also, I'm thankful to you, sir, for Gaurav sir also, and for Deshmukh sir also, for introducing you to us. Thank you so much, sir.
Thank you.
So let us proceed for our next Rupali ma'am for next session. So after a very Rupali ma'am, shall
Yes,
we
ma'am.
proceed for the next session?
Yes, ma'am, we may. Okay, we now move to our second session of the day on the theme IoT applications in precision agriculture. Once again, I request Dr. Shama A. Beg, ma'am, to kindly introduce our expert. Ma'am, please continue.
Thank you so much, Rupali ma'am. So it is my privilege to introduce Mr. Satish Reddy Ambati ma'am, sir, for this session. And after a smart packaging system, we are moving towards another topic, the sixth session of our FDP. Mr. Satish Reddy Ambati is a distinguished professional in agriculture and environmental sciences with over 25 years of diverse expertise in academics, research, corporate agriculture, and institutional leadership. He holds a master's degree in plant, soil, and environmental sciences and a PhD in molecular environmental plant sciences from Texas A&M University, USA. He has worked as a scientist with the US Environmental Protection Agency and taught extensively in agricultural and horticultural universities across Telangana, integrating advanced tools like remote sensing, GIS, IoT, and drone-based technologies into agricultural education. Currently, he is CEO of Agri Provision, Director of Agri Fortel, and CEO of Plant ED, where he focuses on sustainable urban agriculture, AI, ML-driven analytics, and skill-based agricultural education. He also contributes as a board member and policy advisor to agricultural universities, government committees. With his global academic exposure and a strong industry connect, Mr. Satish Reddy continues to inspire innovation, sustainability, and practical learning in the field of agriculture and environmental sciences. I invite Dr. Satish Reddy for his presentation, and the stage is all yours, sir.
Thank you, Sharma ji, for Shama Afros, Madam ji, for a nice introduction. And good evening to all the faculty members of Sri Swami Swarupanand Saraswati Mahavidyalaya, faculty from different universities out here, fellow students and researchers, especially who are trying to get into a new domain as such. So can I upload my
Yes, you can present by yourself also, sir.
Yeah. It says screen. Is my screen visible?
Yes, sir.
Okay. So it's a full screen, so I might not be able to see all the participants there. So, but so welcome all the participants out here, and thank you very much for the opportunity from the Swami Swarupanand Saraswati Mahavidyalaya and also the AICTE program that actually includes my presentation on IoT applications in precision agriculture. So I see when I went into the website of the Mahavidyalaya, there's different domains of careers in the program. So I expect a lot of faculty are from different streams out here, along with the students from different facets also. So I would like to make this lecture much more simpler and more interactive, so that it will be in a one-on-one conversations kind of stuff, but the questions can be taken at the very end. So when we talk about agriculture per se, so what things are coming to the normal terms, and whenever we are talking about agriculture, there have been several terms in the last decade or so. Somebody talks about natural farming, somebody talks about chemical agriculture, somebody talks about integrated farming systems, somebody talks about soilless culture, somebody talks about sustainable agriculture, somebody talks about a new term called as precision agriculture. The whole concept of when we talk about precision agriculture, everything, whenever we say sustainable or precision or any other things, the agriculture per se, we are talking about two things into consideration. One is increasing the yield with a lower resource input and a higher output is one. Second thing is the sustainability over a longer period of time. So whatever that we are trying to do in different kinds of developments over a period of time is either looking at the sustainability or improvising the crop programs or efficient techniques or transparency techniques, so that the production of the agriculture and the income revenue source for the farmer increases around. So for today's topic, we are introducing a topic called as precision agriculture, wherein my topic is going to cover these 5 aspects. The first one is the need for intensive as well as smart agriculture systems. Second thing is the different kinds of technology interventions that are available for the agriculture per se. Third one is the core topic of role of IoT applications in the field of agriculture. The next one is the current hurdles that we already face, or the challenges and the solutions in a nutshell. And the last one is the most important, the case study, which is a real-time case study that we are encompassing. And then I'll try to give you more inputs into those ones. So when we go into agriculture per se, so I think I will come up with something very simple terms to understand for all the fellow students or for people who are in different domains, who have very limited or understanding or anything into the agriculture. So when we talk about agriculture, agriculture is basically done on the earth's surface. Basically, we have only 29% of land, while 70% is covered by the ocean. So we are limited by, out of 510 million square kilometers, we are limited to almost 140 square kilometers, of which only 70% is habitable, wherein we can live and then do something. The other things, almost about 24%, are either glaciers or barren lands. Another thing is, once the habitable land we have, out of that, only 45% is amicable for agriculture. That leaves us only 48 million square kilometers of area, while 38% is forest, and the rest of them are shrubs, which are not amicable for the agriculture itself. Out of that agriculture of 45%, whatever that 48 million square kilometers, we have 80% goes to livestock, and 16% only contributes to the food crops that are being used for food. So whenever we say 80% goes for livestock, we talk about the cropland that is specifically for grazing, or cropland that is used for feeding. For example, if you are talking about US, most of the panhandle, the Midwest, is completely sorghum, wherein the 99% of the sorghum that is only used for feed. So the agriculture land that we have right now for cultivation is only 8 million square kilometers. So now whatever we are talking as around is the amount of specific area that we have for cultivating crops is very, very limited. So whatever that we do has to be done in a right proportion, in a right way, so that we can have more yields. At the same time, we keep this tempo going year on year and generation on generation. So when we look at the contribution of, when we talk about food, we talked about only certain amount of area that is available. When we talk from 1960s all the way to the projection until 2030, whatever the food that is being produced is being used at different perspectives. The first one is in 1960s, almost close to about 51% of the food that we produce were used directly as a food source. And then it has dropped down to 37%, pretty close to, in the year 2010. And then projections toward 2030 is 29.4. So the lifestyles have changed. So whatever the contribution that was in the feed, as the seed that was being produced, or the grain that was being produced, was higher feed. And then it has dropped down to almost about 16% in the linear projection towards 2030. But the export potentials have increased from 10% all the way to 22%. So if you see each block, whatever the different colors that you see out here are all 1% each. So the export has increased all the way to about 23%. While for seed, it was initially very high because we were using a lot of conventional seeds, which used to be a traditional seed kind of a concept. So we used to use multiple seeding mechanism. We used to store whatever that we had and then go for the next generation. So the seed purpose, the grain that is being used has been reduced to 2%, while the processing has increased. And the biggest jump is on the industrial and other uses has been on the rise, because we are being towards the industrial and packaging and other things as well. So when you look at the statistics of agriculture for the year 2023 and 2024, the multiple crops are being listed out here along with a few of these livestock material as well. The food grains, we have 3,322 million metric tons in India right now. But the horticulture is 353 with a very smaller piece of land. The contribution of horticulture is really good. The egg production is 142.77 million metric tons, as well as the fish is 18.4 metric tons of the production aspect. Currently, we are about today we are about 8.14 billion of population in the world, but it is predicted to grow by until 2050, we are going to go to 9.1 billion. So at a rate of 0.8%, this is the world projections based upon the source data. So, but when you have the growth rate of 0.8%, when you see from here on, from the year 2010 and then up to 2050, the production rate has to increase by 70%. That means whatever that has been grown in 1960s, by the year 2050, it has to reach certainly a double than that. So the amount of contribution in the agriculture has to increase by a multifold, so that the entire sessions have been the contributions towards feed, contributions toward other sectors, and apart from that, contributions towards the actual consumption has to increase by 70%. So if you see the heat map out here, if you can see this heat map, in the India, we have the data from MOFAW and from the NABARD data. Whatever the yield gap, we consider it as the yield gap. Whenever we have the white, it basically is that not much of the agriculture is being grown there. And whichever is dark, it shows you that a lot of agriculture is being grown there, especially Uttar Pradesh, Haryana, as Punjab. And then we have West Bengal, Telangana, as well as in parts of Kerala. So the production rate is high, but you see a lot of other areas where there is a little amount of growth, or there is a lot of gap where we can still attribute and we can always utilize this particular opportunity where we can grow further. So when it comes to the reality versus demand, if you see the graph on the top, it is an average size of operational holdings that agriculture in India right now. So when in 1970s, it used to be 2.28 hectares, which almost is about 7 acres of land. In 2015, it has dropped down to 2.5 hectares or 1.08 hectares, which is equal to 2.5 acres of land. And in 2023, 2024, it has still gone down to 0.96. So which means most of the farm lands are operational holding capacities are less than 2 acres or pretty close to 2 to 2.5 acres, which actually needs a lot of farmers to produce certain amount. So when you look down in the screen, you have the demand in the next 30 years or so. What we are seeing here is the production has to, the demand for fruits and vegetables is going to go up by 42%. So there is a huge scope for horticulture and then for the edible oil and poultry and bovine industry. But when you see the milk production and for cereal production, because of milk, because of the feed and additives that are being added, the production will be going really, really high and the demand will be very low in the coming days. But for cereals, because not much, most of the cereals are what we call it as low risk type of crops. So farmers have tendency to have them on and then they produce. So the demand for these ones are going to go low because the amount of supply that's coming into the market is going to be really, really high. So this is what is going to be the trend for the next 30 years. So the question is, now what do we do for this particular thing? Because we have a certain area that we need to do the arable agriculture into it. And then we have very limited resources. And then it has to be a sustainable model. So what do we do? The biggest strong point that India has is, as an agrarian economy, we have built a very beautiful network of different institutes which are working in tandem and coordination across the country, wherein we have about 731 KVKs, which are providing a lot of agriculture support. They do transfer a lot of technology that is coming from the research stations all the way to the farming network. Second thing is the extension personnel. It could be from the state government or from the KVKs or the university systems, and also from the agriculture departments. We have almost close to about 120,000 individuals. We are offering ground assistance at multiple levels and multiple areas of India. The next one is key coordinating entities. We have ICAR, which is the governing body. We have ATMA, we have managers, we have state agriculture universities, we have state departments, which are ensuring the network through the entire system so that everything coordinates well and then everything works fine. And then we have all the information and communication technology startups that are coming up into the platform, which is showcasing a lot of technology for the farmers and also the players in the entire system to utilize the opportunities. We have NGOs, we have farming groups also providing much more assistance so that this could be taken up into second level. There are governmental campaigns, especially Viksit Krishi Sankalp, and then we have lab to land programs and agriculture development programs coming up with the government, which actually creates a lot of awareness among the farmers to understand different kinds of technology, utilize different kinds of technologies to go further into the process. So for any agriculture for that matter, so when we come into any of these things, we talk about the network, we talk about the requirement, but the amount of information that we have to have for an agriculture growth is agriculture predominantly pertains into 3 different factors. The first one is the certainty, which is basically the predictability, because if I'm working with some sort of a commodity, I know exactly how much commodity goes in and how much output that comes out. But for agriculture, it is very, very difficult for us to predict as to what is going to be happening, because let's assume if I'm growing a rice crop, if I am making about 25 tons this season, If I plant the same crop, I'm unsure if I will be able to make it 25, or I'll be making about 30, or I'll be making 20. Depends upon the climate, depends upon the pest, depends upon the different kind of irrigation system. A lot of things that goes wrong or that goes right in a certain situation, and also the physical contributions that farmer does also matters the most. Second thing is the efficiency within the system. It could be the agriculture is a wide spectrum of activities that are involved. It could be from land preparation to seeding, then you have weeding operations, you have other portfolios where we look at what you call safeguard the system. Then you have maturity indices, you have harvesting, you have post-harvest, and then you have value addition, and all of things. So there's a efficiency that goes in. And some of the efficiency techniques the Dr. Bhavish sir was talking about was smart packing. That comes into the efficiency model. And the last one is the transparency among the data. For example, if I am running an agriculture perspective, if I'm in a corporate or if I'm an individual, the transparency of information that has to happen from the operational perspective in terms of seeding and also the operations, it can come in transparency on the financial model, where the market is, how the market is, and also transparency among all the coordinating systems that come around. So this is what is needed. So in order for the growth, agriculture growth, these are the three prominent pillars that we are going to talk around for today. So where do we stand right now? So because the predictability is a constraint, we still have losses about 25% in rice. Due to fungal disease, we have about 26% of yield losses. We have, for pathogens, we have almost about 5 million tons of lost crops across the country, and then 21% is through the nematodes. And we work with tea pretty closely. So we see almost about 147 million kgs of tea lost, which is almost close to about 3,000 crores of rupees. So when we list out all these things happen because we are unable to predict what's happening out. So we are unable to see where the diseases are, where the pests are going to be there, what would be the weather that's going to come up. If there is a hailstorm, for example, in mango, the entire crop is wiped out. Or in case of tomato, because most of the tomatoes are being grown on the ground. So when it touches the ground, there is a disease called as fusarium wilts coming up, and then there are bacterial wilts and all those things, which account to almost about close to 45% of losses. So when you talk about the efficiency systems, so when we talk about efficiency, once it's being harvested, any crop is being harvested in general, I'm talking around, by the time it reaches from the farm, when it goes to retail, we have about 13%. When you talk about post-harvest, from retail harvest to the retailer, and from there to the customer, from there to consumption, you're talking about 20 to 30% losses. So this is because of different kinds of systems that we are unable to do it properly. And when you're in the irrigation systems, we are only about 25% to 35% water use efficiency, and only 40 to 45% in nutritional efficiency. So this is what is one constraint that we still have. And then the lack of transparency is the other one, wherein we don't have a real good unified marketing solutions, wherein we are unable to see margins for the farmer share and also the marketing margins, how it could be dissociated and how could it happen. But most of the time when we talk, people always say, "Jo beech mein hai, wo pura le jata hai. Jo farmer hai, usko kuch nahi milta." So that is always there. So this is where there is a lack of transparency among the individuals, or also on the corporates, and also there is a lot of scope that still has to be done. And then the price information across the markets. We have ENAM coming up, and then they have ONDC, and a lot of things are actually propping up, but still there is a lot of gap in between, wherein the price fluctuations from different entities are there in different kinds of markets. And the next one is on the subsidy flows. Each state has different kinds of subsidy flows, and then subsidies also flow in a different situations. It could be a fertilizer, it could be the initial financial empowerment for the farmer, and also. So the transparency at that level, and also on the financial transparency, insurance policy transparency, and a lot of things are still a constraint. So when we talk about all these things, we can use a lot of technology to kind of address all these. When we talk about technologies, there are several technologies we talk about. So when it could be a biotechnological aspect, because some of the faculty are from the biotechnology, microbiology. You know what is a CRISPR technology, what is a fast breeding technology. We have low light intensity growing agriculture. We have nano fertilizers, which has come up pretty recently. We have pheromone mimics. We have what you call biofortified crops and a lot of things. But today, what we are talking about technology is more onto the IoT's applications and also on the GIS aspects. So how does it work? Is basically simple analogy. I would like to have this, because let's assume I'm not talking as a plant, but I'm talking about ourselves. Our daily life runs normally. So even if we do it the regular way, it runs normally. But when you wear a smartwatch, what does it do? It doesn't change anything on your anything from your perspective, the way you walk or do anything. But what it does is it gives you all the vital signs. Basically, it will tell you what your blood pressures are. It will tell you what is your heart rate. It will tell you your saturation indexes of oxygen. It will tell you how many steps you have to take and how many you have taken today. It will give you how good your sleep was and how active you will be the next day. And it will also tell you, sometimes we have habit of getting into the activities and then forget drinking water. It will tell you, it will remind you, please drink water. It's almost 1 hour that you haven't had something. And we'll always also tell you sometime you have to take some rest. So what is it doing? It is giving you some of these informations on the vital signs. It's giving you an activities. It is also giving you a warning suggestions, saying that you have to do things. It will also create a report and it will tell you, okay, in the last week, your progressive cycle, especially on the sleep cycle, was this much. You have been hampered this times, and then you have had a very, very minimal sleep and so and so. Also, what does it do? So basically, it is creating an awareness among ourselves to understand better about ourselves and also to act accordingly so that you stay healthy, you stay sustainable for a longer period of time, and then you are more active. This is what is going to be done through IoT applications. Whenever we are talking about technologies, this is exactly what we are talking about. We are talking about two things today. One is the remote sensing aspect. The second one is the IoT applications. I'm not differentiating between those two, but I'll be concentrating more on the IoT applications. But my point of view is basically I would like to understand, whenever people say, remote sensing or the IoT applications, they have a kind of an understanding difference. So whenever we talk about remote sensing is sensing something which a body emits, an object emits as a radiation. Whatever I get out of the object, which I capture and then do analysis over that is called as remote sensing. Whenever you switch on a remote through a TV, it is not a remote sensing. That is a IoT. IoT is basically any sensor which actually gives, when you press on something, there is any physical or mechanical changes on the other side. IoT stands for Internet of Things. That means that two things are talking to each other. It is a network of things. When we talk about Internet of Things, it's basically networking among all the gadgets that are around. So when I press a button, there is a sensor which reads and then which sends a signal to the other sensor, which tells them, okay, you do this. Either you do some physical activity or you do some mechanical activity. Like if I press, the fan will turn on. If I press something, the volume of the TV goes up. So it is actually doing some sort of physical activity. So the remote sensing, we do a lot of EM or the electromagnetic emittance, which we capture, but it has to be viewed somewhere. So for that, we use as the Earth as the model, and then we attribute that to the geography. So whatever that's happening, we are putting layers and layers, and then we are visualizing whatever the imminent radiation is coming. So basically, remote sensing is like viewing something on a TV of whatever that you are dreaming. For example, I have a lot of ideas. I'm very good at ideas and then things, but unless I put it on paper, I'll not be able to see what my things are. I will not be able to visualize what it is. So once I have put everything on paper, now I will be able to dissociate, and then I can attach it to one bucket, the second bucket and the third bucket as to which one to do first and the second one, and how this workflow has to happen. Same thing with remote sensing as well as GIS. Similar one is with the IoT applications and the web apps or mobile apps. Whatever the sensors what we are using, it will be showcased in either your phone or on the screen of this thing. So it is a visualization software for the IoTs is basically your web apps or mobile apps. Your remote sensing is your GIS. So why do we use this? Is basically because the difference is very, very evident. When we use the IoT applications, either we we have two sets here. Basically, I'm showing about 5 or 6 parameters: weed control, irrigation, spraying, fertilization, yield prediction on the table, which is out here. Before IoT applications, we used to do a blanket spraying. We used to take a herbicide, it could be a knapsack sprayer or a thing, and then we used to use we used to spray. But after getting to a computer vision spot spraying analysis, especially for herbicides, we have almost about 50 to 65% of the herbicide is being saved. So basically, it is saving your input cost, and it is not overburdening the soil, because herbicide is nothing but some sort of a chemical. So we are not throwing any chemical into the soil which is not needed. So we are basically judiciously using something. Irrigation is the same thing. We used to do a lot of manual irrigation, then we went into basin irrigation, then we went into furrow irrigation, then we went into rain guns and other things, and then we came into drip irrigation systems. So once the IoTs are being attached to the drip irrigations, again we have increased the output of the crops has been increased, while we have reduced the water usage to about 25 to 30%. Same is the case with sprayings, same is the case with fertilizer applications, yield predictions, and so forth. So whenever we are talking about the gains, it is not always the finances. It is also about the time that we are allocating for the operation. We are reducing the resources. Same is with the finances also. We are reducing finances and we are increasing the efficiency. So what happens at the end is basically either your revenue increases or your yield increases, or the quality of the product also increases. So this is what we are trying to do with introduction of technology into the agriculture system. So whenever we talk about introduction of technology, what are we talking about? We are talking about different kinds of areas that we have to look at or focus in. The first one, I'll come from the bottom, is basically the sustainable intensification. So basically, when we are trying to do an agriculture, as I said, the area is limited and we are growing day by day in terms of population, and the land area for agriculture is coming down because of the real estate that is coming up, booming up, because of the mining, because of the urban development, because of the road constructions, infrastructure, and so on and so forth. Most of the lands have been dropped down. Basically, you have SEZ or special economic zones coming in 20,000 acres or 30,000 acres, wherein the land pool is being taken out for industrial allocations. So it does happen across the country. So what happens is we are losing certain part of land. So what are we doing? We have to increase the same amount of revenue or the yield in a limited source of land. So we have to go for intensification, but at the intensification, it has to be sustainable. So for that, we grow at different facets. It could be a staggered mode planting, or data that comes around has to be transparent enough. And then all those things, we use IoT applications. Then we have processing, as I said, the biggest loss, whatever is being lost is not basically, if we are saving something, is equivalent to we are producing something. So when we are not losing something, automatically it is the commodity of the country. Basically, it is the asset of the country that we are trying to save. So the cold processing is one aspect. The extension aggregation, wherein the technologies are always there, but going towards the extension for the farmer. When we say extension, the technologies are always there at the university level or R&D centers or business entities, which will be taken to the farmer for adoption and also for the improvisation of their actual practices. Then is the water and nutrient efficiencies that we are working on, have to work on. The next one is risk management. Risk management could be a pesticide, a pest or a disease, or financial risk, or anything the farmer would be facing. So looking at all the 3 steps, we were taught initially that there has to be a certainty, there has to be an efficiency, and there has to be a transparency. So we will talk about each particularly into detail. So when we talk about certainty, the certainty comes with weather predictability, crop health monitoring, integrated nutrient management practices, integrated pest management solutions, early stage disease detections, and also on the market data provision. So once I know that these I could be able to predict, I have a certainty in my visibility, or it could be a simulatory model, it could be a suggestive model, it could be a predictory model. If I know something is there out there, so that my precision is pretty close to it. If my accurate point is, let's say, at a particular point, how precise I am to that particular number. If I will be able to predict that, it will be much more easier for me to handle the operations and be more financially viable. The project will be financially viable. The first one to start with is The IoT applications that we normally see is the soil preparation and testing. The agriculture starts at this particular point wherein we do preparation, soil preparation, wherein it could be tillage or it could be other operations. We use some sort of sensors, IoT sensors called as soil compaction sensors, because soil physical parameters play a vital role. It could be because when the soil compaction happens, there is no infiltration of water. If there is no infiltration, there is no permeability of water. The water cannot reach to a certain point where it could not be viable for the crop at all. So the physical parameters, it could be soil texture, soil structure, or it could be bulk density, it could be water holding capacity. All these things, along with the microbial activity, will also be hindered, especially when you have soil compaction. So we'll be using some of these IoT devices for that. Second one is the GPS guided land levelers. Basically, the land is not uniform in terms of fertility and also in terms of topography. So when you have a terrain kind of a stuff, even if you do tilling through a tractor or any other equipment, it is not leveled. So when we use GPS guided leveler, we will be able to ensure that it's leveled, because once it is leveled, the water or anything for that matter, whatever gets in is equally distributed. If you have a terrain, automatically the water along with the soil is being eroded. So the topsoil is gone. When the topsoil is gone, your entire fertility is gone. And then the soil from the top layers is gone, but it goes and then stagnates at a certain point. If your crop is at the very bottom, then you are lacking respiration. Your crop loses respiration because the entire roots cannot have any oxygen anymore. So they die. So for that, GPS guided levelers are used. And then we have smart soil sensors. When we talk about smart soil sensors, this is basically gives you all the information on different kinds of nutrients and also on the physical parameters, like you have pH, you have EC, you have organic matter carbon, you have nitrogen, phosphorus, potassium. And apart from those, we have micronutrients also. So it could be a probe that can go in, and then it will give you a basic needs which a crop can be taken. And the soil sampling can also be done through other chemical analysis also. But this will give you a right on immediate analysis, like we call it as a mobile analytics, which will give you a rough ballpark idea. So with this, what does we gain is basically we can alter the dosage and also the quantity of nutrient that is required by the plant, because we don't want to put whatever is, we will do whatever is needed. Not that it is an art and a practice. So I'll be putting in 2 bags of urea or something else. We take only what is needed. Second thing is we'll be able to understand how the crop cycle works and how the nutrient dynamics work. And then the last one is basically we'll do some sort of physical interventions so that there will be a sustainable model for a long period of time. Second comes is once the land is prepared, we comes to the planting. So once the planting is happening, we have to have some sort of a mechanism wherein somebody should be able to suggest us what is the right time. Because most of the time from the ages and generations, we have been used to a certain time. In the southern India, we are used to the southwest monsoons. So once the monsoon starts, during the June, July time, we start to plant the Kharif crop. So we actually are, it's coming like an art. But if we have some sort of an app, or if we have some sort of a solution which can tell us the southwest monsoon have reached to Kerala, and it will take maybe about 15 days for it to reach Andhra Pradesh or to Telangana, it will be much more easier for me to plan my operations. And it should be able to give me a lot of crop calendar as to how it has to operate and what is the thing and how which crop could be sown. It could be a variety or it could be a hybrid, and where I could get it, and then what could be the pricing of those and everything. If I could get this information through my apps, it could be the wonderful thing that I could have. So what does these apps or applications through IoTs will help me is to provide me a crop calendar. It will also tell me how the plant density and yield should be. Initial days, for example, if I take mango, we used to plant at 20 feet distance. And then later on, it became 10 feet distance. Now the ultra high density. So now I'm talking about planting spacing is only about around 6 feet. Or even 5.5 to 6 feet between the plants. But I'm getting more yield, so that the planting densities can be adjusted or altered depending upon the requirement, depending upon the intensification, and also depending upon the financial availability of the farmer as well. And now it also gives me an opportunity to choose what of the different kinds of varieties or hybrids that I can use for my program. The next one is once I have planted something, now I should be in a position to predict my weather. So for which the weather stations will help me. So how many weather stations do I require? Maybe once in one weather station for about 5 kilometer or 10 kilometer radius, or even if at all we have a cluster of villages, one weather station, it will be because most of the time the microclimate changes a little bit, but the entire weather of the entire area pretty much is reasonably similar. So we can take to about like 30-kilometer radius, we can have one weather station, wherein we have wind directions, we have anemometers showing us the wind speeds, it gives you the solar radiation effects. It also gives you the rainfall indicators. It will give you relative humidities. It will also give you other aspects wherein you have the sensors which are fit in to understand the soil nutrients also. So wherein it will give me an understanding as to what's coming out. For example, if I know that the rainfall might be there the next day, I will hold on to my operations of spray of a herbicide or pesticide or anything, which will save me a lot of input. It will not only save me the finances for buying the herbicide, but also the time and also the energy that I put in terms of my workforce or my water also. So it will save my inputs and also on the finances. So once this is there, we go to understand what my plot is and where my situations are and where I need to be more precise in applying some of these. So this actual weather predictions and also on the monitoring of this particular area will tell me how should I plan for tomorrow or the week after that or the month after that. It will also tell me what is the imminent calamity that is going to happen. Is there going to be a hailstorm? Is it going to be windy next day? Or how does my weather fares out the given next day as well? So based upon that, I'll be able to do some precision application possibilities. So coming to the next step is basically once I'm into the cropping system and I'm growing my crop, the next part is my pest and disease. So basically I should be able to understand, because basically nowadays what happens is a farmer plucks out a leaf or a plant and he takes it to a shop and then asks, sir, I have this problem. Can you suggest me something? Whoever the trader or a shopkeeper might be knowing something or might not be knowing something. So he gives out some sort of a chemical along with all the nutrients, all the things which might not be needed for that crop at that particular moment. So the entire loss is on the farmer because he might not be able to address the problem right away. But at the same time, he's going to lose a lot of his money and also his strain. And also at the end, he might not be able to get the same amount of result that is tend to achieve. So there is an app. There are multiple apps. Plantix is one of the famous app wherein you just have to go to a plant and then you just have to snap it, and then it will take a picture. It will give you exactly what is is it a disease or is it a pest or is it a disorder or is it a deficiency? It will tell you all about that. So based upon that, you will be able to. It will tell you what has to be done, what is the stage, what has to be the preventive measures, and also what is the curative measures, what needs to be done through organic way and what has to be done through an inorganic way. So it will give you much of an idea as to how to deal with this problem. So let's assume you are not preventing it. So once the pest is coming in, you should be able to at least address as to what is your stage wherein you have to take some sort of a measure. So for example, if we look at the very right hand corner, this is basically detection of pest and disease through an AI based optical lenses. So when you look at the lenses, it will tell you exactly based upon the reflectance patterns. It will tell you what is the disease. Once you have already put it into AI and then read through the systems, it will tell you what is the disease or what is the thing that is happening on the pest, and it will guide you as to what is going to come. So there are going to be situations where if you see at the bottom again, you have spore counters. When you have some sort of a spores, it will detect all these spores. It will have all the spore count and it will tell you this has happened in the last 1 day or 2 days, and then you specifically look at what is going to be the procedure that you are going to follow. So if you are looking at the top ones, is basically the traps. It could be a pheromone trap or it could be a light trap. These trap these insects, and then based upon the ETLs, we call it as economic threshold levels, the number of insects that actually are there which could harm your crop. Once it reaches beyond this economic threshold limit, then you have to go for some sort of a pesticide application. It could be an organic or inorganic, or you can do some sort of a physical contribution or a biological contribution to reduce those ones. So what does it tell me? Basically, the IoTs will help me to understand how the pest dynamics are happening, with what time they are coming in, what is the possibility that they can move from this particular direction to the other direction, and also what could be the damage or extent of damage that could happen. so that I can plan my precise applications and I can also remove my resource optimization. Because if I see that there is going to be an intensive problem in this particular area, I might not be able to spray the entire area. I'll be concentrating only that area where there is a required need, so that I'll look at lowest input and I'll be able to apply for larger portion of, not a larger portion, more impactful applications could be done. So coming to the second point is basically on the efficiency. When we talk about efficiency, we could do at efficiency could be brought it at production level. It could be on soil preparation or seeding or germination. It could be on irrigation or fertigation, crop growth or harvest, and it could be on space and resource utilization as well. So when we talk about seed and germination perspective, is basically we have IoT applications which have visible cameras which will tell you exactly how many number of seeds have to be planted at what spacing and what depth. So the IoTs will help the planters to exactly follow a specific line and exactly place them to the population density that is required by the or prescribed by the farmer or an organization. Second thing is the dry seeding technique, which we use drones as one of the areas wherein seeds will be sprayed through the air and then it will be covered. So what are we trying to do is more acreage with a limited amount of time and precise application of the exact fertilization, exact seeding techniques that we'll be able to do. The next one is transplanters. We have IoT-based transplanters wherein the plants, once they grow from a seed to a plantlet stage, they are being transplanted exactly at a certain specific distance, like what we do for a seed. So these transplanters also are guided by a vision through cameras, and then it will help the tractors to roll around, and then they are specifically planted at a certain period of time. In the bottom, you see a map which actually gives you a germination map. Based upon the germination map, we are able to precisely map the entire crop area to understand where our germination losses are or where we need to address it in a better way to understand how things happen and then where my resources have to go in. So what are we achieving through this is basically more coverage per unit time and uniform and optimal coverage, and definitely the labor cost is reduced. Coming to the nutrient and pest management or irrigation management per se, we have two things. Basically, we are using IoTs and efficiency management, especially on the waterfront, through irrigation controllers. We have seen most of the farmers are now using the IoT-based motor controllers. Basically, they will switch off the motor and switch on the motor from their home. So this is an irrigation controller that is predominantly used by the farmers, and that's has been coming in the market. Second thing is what you see, and the next to that is again an irrigation controller which we predominantly use as a manual controller. It's a timer. So because if I'm using it indoors or on the rooftop or on the landscaping and other things, I'll be connecting it to the motor, which will exactly tell the motor when to start and then until what time it has to go and when to shut it off. So it will have a solenoid valve when it will allow only to that particular timeline for 5 minutes, and all the drips will go for 5 minutes or 10 minutes or 15 minutes, whatever that you said, and it will go shut out. And then you can always give it an interval, once in every 30 minutes, once only twice in a day, or once in a day, or once in 2 days. You can always manually give up an interval or a calendar for it to execute. So exactly does what is being prescribed by the owner. Okay. The next one, what you see on the right side, is a smart fertigation controller. So this is more an advanced mechanism wherein all the nutrients are being placed in the fertigation tanks, and then this exactly draws this volume, whatever is required, and it pumps into the irrigation system wherein the drips will get all the plantations or all the cropping systems will get exact fertilizer that is required. So it takes nitrogen from one source, it takes the micronutrient from other source, it takes organic manure from other source, it draws out exactly at the volumes being prescribed, and then it draws it and then it distributes to the crops itself. At the bottom, we have automated sprayers. Now, when we go into the automated sprayers, it exactly does whatever that we have talked about in the previous slide, like the seeding as transplanting. We exactly prescribe whatever has to be the spray volume, and also the amount of speed that it has to go to cover the area. So it will exactly look at the cropping area, and it will do the cropping. And then once the crop is done, it automatically shuts out. And then once the crop starts, it again starts back again. So the automated sprayers will help us to uniformly cover the area. It will also reduce the input usage as well. When we go to the next stage is basically on the crop growth monitoring stages and also on the interventions. We use multispectral imagery and also hyperspectral drones to actually look at your crop. For example, if I give my crop and I do a geotagging of the entire area and I start monitoring it once in a week, so I'll be able to tell, or the application will tell me exactly where my problem statements are. Basically, it could be if it will be color coded. If it's red, it is saying that there is some sort of a problem. It is yellow, it is cautioning me. If it is green, it is telling me that it's okay. So if I say red, I should be able to understand, is it by a physical damage? Is it by a stress due to water lacking of water? Is it by a pest, or is it by a disease, or it by a nutritional deficiency, or is it by something else? So once once we go there and then we understand which part of the area is it, because of the low level, if you do a digital elevation mapping, you will be able to understand all the low level areas will have a problem when it's a rainy season because of the inundation of water. The humidity goes up and the pest also goes up, especially on the sucking pest will go up. So it will tell you, based upon the hyperspectral imagery, it will tell me the crop growth every week time. And so that I can take measures to counter it. The second one is fixed field cameras. Looking at the fixed field cameras, it will be able to tell me how many people are working there, what my crop status is, what my things are, and what are the operations that are happening, so that I'll be able to see how many attendees are there, how many times we have been working, and what is the actual thing that has happened on the ground. It could be the fixed cameras can be put in on the farm itself, or on the operations or value addition or harvesting and post-harvest operations that we do as well. The next one is on the crop. We have some other IoT devices wherein we are talking about canopy readers, wherein it will scan the canopy and it will tell me the humidity levels, it will tell me the crop indices, it will tell me the evapotranspiration ratios and all those, so that it will tell me the health indexes, so that what is the next stage I could be able to plan something. So what is that I'll be able to get is basically I'll be able to estimate what my optimal yields that are going to be there after 3 months of my crop. Depending upon the entire cropping cycle, I'll be able to judge what could be my yield, pretty much around 10% here and there, what could be my yield. So that I could plan some interventions, or I could make sure that my infrastructure is ready, my warehouses are ready, my market is ready, my logistics are ready, and all those kinds of things. So the next one is crop maturity identification and harvesting. In this particular scenario, we are using IoT devices basically on the optical side, wherein the cameras will identify the plant from the fruit based upon the reflectance patterns and also on the size as well as the color. It will tell me if it has matured. So automatically the plucker will go and pluck it out. It could be optical based or it could be a touch based. When you are talking on the ground level, it is on a touch based. Basically, like, for example, if you have a lemon tree, you cannot see the fruit. You have to put in your hand. You get a touch and a feel, and automatically you try to pluck it. So it is the touch-based thing. So not you, even though you are unable to see what is there, this particular sensor will go inside. If it is based upon the touch, it will understand based upon the complexion and also on the size and other things. It will touch and then it will do the harvesting itself. The next one on the right side is basically the GPS-based harvesting. So I'll be getting it what distance it has to harvest and when it has to take a turn. I'll automatically, and then it will go and do the harvesting for itself.
Please mute your mic.
So the cropping, especially on the most of the time, it could be a maize or it could be cotton or it could be anything. The harvesters work across the world on the same smart irrigation or smart harvesting mechanisms. And then we come out to the one called as non-conventional agriculture applications. The IoTs are predominantly used in hydroponic technology, wherein it will sense the nutrient status and it will give you a right kind of a thing. It will tell you what the pH values of the solutions are and what is the EC conditions, what is the light intensities, what is the growing parameters. And then a lot of sensors are involved, wherein it will tell you the ambient temperatures also, and like lux parameters, especially how the crop is growing. Second thing is basically on the right side, we have the second slide basically on the vertical farming concept, because most of these thing that's happening in the training is the microgreens, for example, or you're talking about the different kinds of crops which can be grown vertically. It could be for a feed as well. Wheat grass and other things can be grown vertically, wherein you are using lights and the sensors to understand the growth patterns. You are using infrared lights and also some sort of a UV lights in order for the crop to grow really, really well. The bottom one is basically the cold chain farming technology, especially for saffron cultivation. We use we have a small thing called as vernalization. So for a saffron crop, it needs certain temperatures around 3 degrees to 4 degrees centigrade when it has to flower. So if we can't provide that temperature, or the crop is not at that temperature, it will not flower. So the basic commercial aspect of the entire crop is the stamens. So for that, we need to have a flower. So for that, we use cold chains or cold storage rooms to cultivate this. So anybody with small cold chain can also do saffron farming. This is the upcoming trend. So wherein we use a lot of these IoT technologies as well. And on to my left of the slide, this is called as airdrop technology. This is growing crops in deserts, wherein the ambient atmosphere or the moisture from the ambient atmosphere is grabbed and then it drops and it condenses all that, and then it converts that into moisture, and that moisture is being sent to the crops, so through the root system, so that the plants can grow, because the ambient temperature outside is really, really high. So the amount of irrigation that we will be able to do is going to be very limited. So based upon the humidity that's available or relative humidity, you grab those and then you put it to the plant systems. So for this, the IoTs are used for temperatures, irrigation, lighting, and also on the nutrient management aspects. So this is where the efficiency comes in. The third aspect, what we are going to talk about, is transparency. When we talk about transparency, we are talking about farm level transparency on the input usage, operations, yield estimations. We're talking about resource optimization, market level transparencies, and then you have farm to fork traceability. So when we talk about the transparency, we are talking about farm level production. These are all the areas that I was talking about earlier. So basically, the transparency needs to be done at farm level. It needs to be done at supporting, especially on the supply chain logistics. It could be on the pricing market. It could be on the safety and food quality, resource optimization, financial and insurance, and also on the consumer transparency, where I should be able to know where this particular crop has been grown and how many days it has been in this particular go downs and other things, and when it has reached to me. So there are several interventions. I have listed a few to understand, especially the load sensors, especially the lysimeter that you have on the right side. Basically tells you exactly the amount of volume of crop that is being grown for a unit drop of water. The lysimeters or weight sensors are being used for several weighing scales, which are connected to your dashboards. It will tell you exactly what is the quantity is being harvested exactly at that particular time, so that you will know what is going to come out into the market. Second thing is, whenever you are going into market, everything is smart packaging. Dr. Bhavesh Garu has pointed out all these smart packaging concepts. It could be a barcoded ones, it could be a QR based ones, it could be an RFID ones, it could be a temperature sensor ones. So you have packagings that is all driven by the IoT things. Then you have grain quality sensors, wherein you put in these grain quality sensors in silos, especially if you have grain silos which are about 10,000 metric tons or 10,000 tons or things which are for feed applications, which are at your FCI go downs. Once it is under these silos, the temperature, especially in the middle of these grains, goes really, really high. So automatically deteriorates the quality. So based upon that, if you have sensors in there, automatically the blower starts off and then it starts to cool down the temperatures of the entire grain. So these IoT applications are used for grain storages. And the last one is basically on the automated grading and sorting machines, especially for fruits and a lot of things, especially on the post-harvest technology instrumentation, are looking at optical sensors based upon the reflectance patterns, based upon the size, based upon the color. It will grade and then it will put it in different baskets so that the quality assurance is done, and also the size is being graded properly. And we have other interventions like cold chain monitoring. So for example, if you have meat products or fish or eggs for that matter, or in agriculture, for example, medicine and aromatic, basically herbs, when you put it in at a certain temperature, high temperatures, they lose all these volatile compounds. So like geranium or mint or anything. So they need a certain temperature for them to transport from the harvested crop to the actual market, or somewhere you actually store it. So this is where the cold chain monitoring sensors are there. We will be able to judge what exactly the temperatures are in the van when they go and then when they reach there. And then you can track where your shipment is, basically from the RFID trackers or RFID readers and other things. You will be able to judge where it is and how you have to adapt. For example, we work on tea. So in tea, once we have loaded our truck, then only the heaters in the actual processing center will start. I don't want to heat my entire premises before getting there, so that I will save on my energy. And once the vehicle comes there, automatically I will load it up. So this will help me to reduce my energy efficiency as well. Then there is one called as ethylene gas sensors, basically for banana and other crops, wherein you are doing a lot of what do you call to get to the maturity, so that they will be ready for market. So for maturation and do things, we use these gas sensors. So these are sensors that are used to ethylene. The next one is shock and vibration sensors. Shock and vibration sensors are used for daily operations or for different kinds of aspects, wherein, for example, if you are using a drone or any other equipment which is under vibration, most of you know NVH, noise, vibration, as well as harshness. So when there is instrument is what do you call getting to has a possibility to get failed in a given time. So this sensors will tell you that it has a life. Maybe it might run for about month time, or it needs a servicing for it. So it has to be brought down and then does the servicing, so that there is no downtime for you in the aspect. And then the data transparency can also work on mobile marketplaces. For example, if I am working as a farmer, I should know where my markets are, so that I'll be able to see where my markets are and wherein I can go take my product and then sell it off. Second thing is my market forecasting, basically the pricing indexes, especially ENAM will tell you which market gives you the better price for your product. At what stage is your crop, at what kind of quality is your product, and how near is your farm, and what would be the price that you might get. Next one is the payment gateways. So basically, when you do the transparency of transactions, your blockchain technology, which also handles this payment gateways, also to connecting from one end to the other end, wherein the payments will be done instantaneously once the product is reached to the intended trader or buyer or the consumer itself. The last one is the traceability aspect. When you're talking about the traceability, it will give me the quality assurance, especially on the food safety, and also it will tell me exactly where my product is. You just have to scan a barcode which is listed on the package, and you'll know when the crop has been planted, what are all the chemicals that are being used, when it has been harvested, when it has been processed, and when it has reached to the shelf. So you will know exactly what you are paying for. Somebody says organically grown. Now you know exactly is it really organic, or is it something, when they say organic, is it only naturally grown or chemical free agriculture, whatever is that. So you will be able to know what is the traceability that you can get around it. So looking at all the trade transparencies, you will be able to see the real-time data, so that you can make a proper decision for your benefit or also the organizational benefit. And you have options for you to go beyond the reach of your thing, so that you can get more revenue or more bang for the buck. When you are trying to sell it at a different place or for a better margins, you will be doing it. And as a customer, I'll be knowing where my what's happening to my product. And also with all this transparency, I'll be able to reach to not from B2B, but also from B2C or directly to the customer, D2C market also. So looking at I have talked about all the application parts. Basically, I talked to you about different kinds of applications that are on certainty, efficiency, and other things. Now I want you to see in real time, because this is what I want you to understand about the organization that we are in. So AgriPhotal is an organization which is a data-driven agriculture organization, which is purely into AI and ML. We use a lot of IoT devices to understand different kinds of situations. So wherein the process is very simple. We take the imagery from satellite, from weather stations, we take from drones, we take input from weather stations and also from human tracking, and then we convert that to the platform. We analyze that data, we transform the data, we conclude with basically on the historical data, and then we tell them as to what is there and what is going to be the problem, and how you have to encompass this situation, and then we'll provide it to the mobile app to the farm owner. So it could be on the organizational front, or it could be on the farmer front. We are addressing three problems. One is the transparency. Now there is zero transparency in certain issues. So we are addressing the transparency. Second thing is we are helping the organization or the farmer to take better decisions and quality decisions at the right time. And the third one is they are unable to figure out ROI, so the return of investment on different areas of their application. So we are actually providing them solutions to understand where the problem is, and if you are doing this particular intervention, what is going to be your ROI. So we have automated a lot of things on the data source itself. So what do we do and how do we do it? So what we do is basically we have all the things as I talked about. We have introduced weather data, soil data, we have drone data. We put it all into the big data concept, and then we have all the AI modules. And what do we give out is basically real-time analytics. We give them reports, we give them anomalies. So if something is happening differently, so we'll try to do the anomaly detection, and we'll tell you something is wrong right here. So I want you to go check it out. And then second thing, the next one is basically we give you terrain analysis. Once the terrain analysis is there, we work predominantly in Nilgiri Hills. So it's all hilly area. So our terrain analysis is such that if at all your crop is towards the north corner, north side facing, what would be the amount of light intensity that you're going to have? If it's on the south facing, this particular plot is going to get this much. If it is at the bottom of the things, these are the problems that you're going to encompass. So, and then we give you visibility into the entire operation structure. What is the input? What is the inventory that you have? How many people have worked? What is the operations that are being done? And what is the output and everything? So from the transparency in operations, we give them 100% visibility and control. We have achieved almost 30% increase in the yield for all the corporates that we have been working today. And then for the disease management, we have reduced almost about 28 to 30% of loss in the crop that we have achieved. Now, we told you how we do. Now I'll tell you how we do it. So basically, when you see on the right side, basically on my left side or on the screen on the left side, we take the data sources basically from weather stations, soil sensors, from the operational data, satellites, and all those things. We draw it through the data streamlining, and it goes to AI models and big data. And from there, we use comparative data, predictive. It could be a suggestive or based on the similatory data that we already have been doing on historical thing, and the real-time data. We produce it to the farm manager, who actually gives back to the supervisor as such. Once the supervisor looks at it, and then he goes back and then gives me the data back. Once this data is given out, it goes to the administrative section. It will tell what are the operations that are being happening and how to look at it. So once that data is given out to 3 of these group individuals, especially at the organization level, we give them in different kinds of things, wherein we get reports, you get dashboards, you get notifications, and we also give them a chatbot to understand what is the real-time monitoring that we do, which is at the bottom of the farm operations. It could be a daily progress reports, it could be chemical usages. In the comparative analysis, we talk to them as to what was your target and what is the actual right now. What is the cost analysis that you are having? What is the research telling you to do, and what are you actually doing it? And what is the company guidelines that are actually there, and what is the actual data we are achieving there? Predictive analysis, basically we tell them how the weather activity is happening, how the yield predictions can happen. So how do we do is basically we actually geotag the entire area for each plot separately, and then we tag it, and then we put it onto the app, and then we train all the farmers and also the supervisors at that particular facility to use our app as to how you have to get the data in. Once the data, when they understand where they are doing, they have to capture the data. The good part of this is basically I can't sit at my home and then enter the numbers. I have logged it to about 50 feet, or maybe about 100 feet. If at all I am crossing that border, let's assume I'm talking about, you see a plot here, basically CH08, CH12. These are all the plot numbers. If I'm taking the data for CH08, if I am crossed the borders and gone into somewhere else, I will not be able to enter the data anymore. So the person has to be there to enter the data. It could be anything. It could be inventory. It could be disease surveillance. It could be on the regular operations. It could be harvesting. It could be lane cutting. It could be foliar applications. It could be irrigation. Anything. So basically, whatever the data is being there, it is being captured right on the ground. And exactly, I know if the harvesting is done, I know exactly how many people have harvested. I know exactly what kind of harvest has happened, how much quantity has received, and how much area has been covered in particular day. Is it the temporary worker has done very well? Is it the permanent worker has done very well? How much averagely that I have gathered and all those things. So once I get the data, now the data is again associated with the weather. Now I'm looking at the data, I will also plan my next day. Basically, if the weather data is temperature, humidity, or any sort of basically on rainfall, if I have something, then I'll schedule my operations in different way. So I'll be able to plan my agri operations. If you see on the second one, basically out here, basically I have a listed out operations every given day. For example, if I have sprayed the crop for with some pesticide, it has a residue effect for 13 days. Let's assume it has 13 days. My harvesting will not allow, basically my calendar will not allow me to harvest it before that. So I have to harvest it only on the 14th day. And it will tell me exactly, it will give me a time window of only 2 days. After that, every day will count. So whenever I'm losing a day, it will tell me you have missed 1 day of harvesting and the 2 days of harvesting, 3 days of harvesting. Because once the days of harvesting goes beyond a certain point, the quality of the leaf, especially on tea, goes bad. So the harvest has to be exactly to the given scenarios, and then that's how we harvest. And going to the next one is basically on the crop growth and also on the water stress, because we portray and we overlay a lot of these data through the satellite imagery and drone imagery, and then we showcase how much was the cloud cover, how my NDVIs and NDMIs and also on the NDWIs are acting around. What is my water stress analysis, where my crops are going bad, and then where my crops are doing same thing. Basically, whatever that we talked about on the crop monitoring, whatever we talked in the earlier slides as to how the crop monitoring happens. This is what we do on a real-time basis every given day. So apart from that, we also do the disease detection. So we have trained the system or the AI ML based systems on the algorithms on blister blight is another disease what we actually figure out, and then second one is tea mosquito bug on the pest. So based upon the reflectances, based upon the cropping type and also on the leaf type, it actually the reflectances is captured, and then if the disease detection happens, I'm doing the regular analysis. Basically, if I'm a supervisor, I'll go there and then I take snap, and it will tell me based upon the number of leaves that I come across. If I take a picture, it will automatically pull it and then say this is the disease and this is the amount of the level this particular disease in. And if I am looking through a drone based, I use hyperspectral imagery to understand what my disease potentials are and how I look at beyond that, so that I can plan my operations for spraying around. Next one is basically on the optimal population and yield estimation. So if you see the map onto your left side, basically I have all the operations listed. I have all the populations and also things. Basically, each crop area field area is being mapped differently. So when I look at it in my dashboard, exactly it will tell me where my pruning is happening, where my foliar spray is happening, where my harvesting is happening, based upon the color coded things. You see a light blue, it's pruning. If it's a little dark bluer, it's foliar spray. If you see a red or the red color, then it's something else. If it's green, then harvesting is going on. So it will tell me, because this is a very huge area, so we will be able to monitor exactly what is happening. And the next thing what we do is basically on the vacancy analysis. On the entire crop, we scan the crop and it will tell me exactly where the crop is being lost, where the plantations are lost, and if I have to do a replanting, where is the first field that I need to approach so that I can plant more, and then my populations are optimum so that my yield can be actual to the target based. So, and I also get the leads basically on harvesting. I have a historical data for last 5 years, and it will give me what was my last year and how it is faring out this year. And also, if you see on the right side is basically all the bar graphs. It's giving me what my data is by month to month basis against the budgeted and against the actual. So the next one is basically, as I said, anomaly reports. If something goes wrong, automatically my notifications will come. It will tell there's a unsafe harvesting done at this particular harvest. It still has 2 days to go, but somebody has started harvesting. So this is what it's going to come out. The next one is if something is happening on the quality and operational efficiency. When somebody is doing an operational efficiency, if something is not right to the proper, it will tell me what is the statistical difference that as the mean deviations from the actual point. So, for example, if a field has to be harvested by 12 people in 3 days, if somebody, only off around, if I still have 12 people, but if they are, rather than doing 3 days, if they are taking 5 days, it will tell me the amount of timeline that's being lost and the amount of resources that's being lost. So it will give me all those operational efficiency analysis as well. And the last one we have is basically on the power chatbot, the AI. We have all the data sets inside. So if I go in and I just ask a conversation like your chat GPT, if I ask, say, compare whatever has happened in the last year, you tell me what was my, what do you call, the improvement or some sort of a thing that has happened in the since last year. It will tell me about my irrigation patterns. It will tell me about my rain. It will tell me about my harvest. It will tell me about my cropping. It will tell me about everything. What was the amount of percentage that has been lost through disease and everything. So it is a chatbot. I can just immediately prepare my document. I can prepare. I want the report to be done last 3 years. It will give me a report straight away within 30 seconds or 10 seconds, and it automatically, I can use that immediately on my screen itself. So it becomes very easy for the management, especially on the organizations, especially on the state agriculture universities or any of the organizations, to present it to the investors or for the boards and also for the higher officials as well. So what we are trying to do on the impact of the end of the day is basically we are trying to improve the crop health, because we are ensuring that not many harmful chemicals are being sprayed. So we are judiciously using all those. We are lowering the input cost so that the farmer or the organization benefits well. It is profitable for the farmer because we are improving the quality. We know exactly when it has to be harvested. So we are retaining the quality. We are retaining the resources as well. So the quality is good. So automatically the profitability or the margin of profit will be very, very much higher for the farmers. And the last one is traceability. So now we know exactly what is the inventory that has been used, who has done it, when it has been done, when the harvesting has done. So I know exactly what has happened in the entire spectrum. So I have a traceability to look at. So this is the case study that we are trying to do. So now I want you to understand in the real world or in the global scale or the Indian scale, what is the interventions of these IoTs in India. So they have had a real-time impact of yield increase of crop by state. Is basically they have looked at Punjab. In the crop of wheat, they have looked at 18% of yield increase. In Tamil Nadu, they have, with the irrigation systems of management, they have done 15% increase. In Maharashtra, they have 20% increase in cotton crop at different times of pest management strategies. In Uttar Pradesh, it's 12%. In sugarcane, 22% in Madhya Pradesh. So, and same thing, savings basically on irrigation management, they have looked at 30% in Rajasthan, 25% in Gujarat, and Karnataka 18%. I have the source data for if someone wants to look at the entire data sets and everything. We have listed data source, so you can go and look at into much more detail as to what has been taken, which crop and other parameters as well. The same thing is basically on the digital agriculture, especially we have looked at the increase in input cost. Is the cost has reduced to 5,000 rupees per hectare, and then the average yield per tons has increased from 3.5 to 4.2 tons. The market price has increased by 10% from 20,000 rupees to 22,000 rupees, and profitability especially has jumped up to almost about say 80% or 90%, I would say. So from 20,000 it has jumped down to almost 38,000 rupees. So what is and then we also have the adoption rate. When we are talking about IoT applications, the adoption rate is for the larger areas, this is almost about 35%. And then we have medium farmers, which have acreage of about 2 to 10 hectares, which hover around like 13%, and smaller holders almost about 3%. So I have reasons for that as well in the next slides as well. I'll talk about things. So at the end of the day, we talk about everything we talk about IoTs, technology has come in, and then yes, everything could be solved. But if I say everything could be solved, then what is the problem and where is the problem? So the question is basically the adoption is the biggest concern, because the initial cost of the IoT applications is still high for now. And then there is a poor connectivity of internet across in the rural sectors, and then lack of awareness is the biggest concern in the rural farming network. Because of the lower income generation, their awareness is a little lower through the internet facilities. And then fragmented holdings, because as I said, the acreages have been split down into their as an ancestral property or something else. The holdings have been fragmented, so the amount of land is very low. So, but the amount of investment that I put in into a IoT might not be really feasible in the smaller perspective. The next one is the power supply issues. Because if I at all I want to have some data to be given out to me, I have to have a continuous power source, which might be lacking in the rural fronts. The power generations have been increasing, and we are reaching there. Yet we are not yet there. So still we have some power issues in the rural front. The last one is the data privacy issues. Some of the data which is being captured by the local companies still is being put out, and then there is still a privacy issues on the data as well, because the instrumentation data can go into different places. So how do we go about these solutions is basically, as I said, we have an extensive network of KVKs. We have extension network of all the different ICT technologies and everything. So we use those leveraged technologies to increase the market linkages and incentives for all these produce, so that the agriculture income improves, especially at the bottom level. And then there is a direct linkage or the forward linkages from the farmers itself to the market or to the business entities, so that the price gap would be stabilized, and also it is viable for the farmer itself. Next is on the cost and accessibility. So when we talk about the cost, we are talking about the subsidies, providing subsidies by the governments and other things, and also on different aspects on fertilization or irrigation, or on the seed, or some sort of a initial investment to start off their crop as well. And also to lower down the cost of the IoT devices. If the government can provide some sort of a systems wherein the lowest IoT devices, which actually can give out more importance on the crop production, can be taken at a lower cost as well. And then there should be some sort of a provision, especially like KVKs and also grow more centers and other areas where they have a wide network. They can start a rental basis, like what we have equipment rentals. They can also start these small gadgets which can be used for a rental basis on a small cases. The next one is on the connectivity and the rural infrastructure. Extension network has to be improved. Solar power devices, as the Prime Minister's program has already started. The solar power networks will come in, and then probably we'll see something on this aspect. The sustainable support systems, or on-ground thing, is basically we have on-ground technical assistance, we have warranty and maintenance, and also on the continuous feedback loops that could be taken up. And next one is localized solutions, because if at all I have somebody who can have some sort of a if something goes wrong, somebody is there to train me or do a maintenance aspects, and also provide me IoT packages for customization at my farm, then that is wonderful. So if I can improve those localized conditions where my solutions can be optimized for localized areas, for different type of cropping systems, for different kinds of markets and different kinds of situations for a farmer, then that will be wonderful. So then again, the solution could be on the awareness. As I said, the education programs like farmer training programs can be taken up at KVKs or farming centers or any other institutes, or the universities as such. Literacy campaigns can also help. The last and the most important one is the partnership and ecosystem. Basically, agriculture is basically as a bigger format. So we need public-private partnerships wherein still is there, but there is still a scope for a lot of companies to pitch in their activities, help take care of NGO involvement, and also the academic involvement can also happen. The cooperatives, their FPOs, several networks can also work in tandem and coordinative effort so that it can happen. So before we go into this summary, basically, whatever is basic, we have talked about a lot of things. I want you to look at this particular thing. Basically, is if I can hear, basically, my analogy was basically if you have a smartwatch, whatever is telling me, the smartwatch is telling me, I am able to understand. But if I am able to understand what a plant is talking, whether it's thirsty, whether it's hungry, whether it's stressed, does it have perfect soil moisture, has a small problem in pest or anything else, if I will be able to do some sort of a mind reading, then it is wonderful for me. So this is what an agriculture, especially on the IoTs, does. So it gives all the information from a crop, and it will give me all the data, and I should be able to figure out what is happening based upon the logistical or logical conclusions based upon the university information or the information that is being provided by the what do you call the instrument itself. So what is happening is basically when you are going from unmonitored farm health, we are going towards a farm enhanced farm health. We are giving out a farmer real-time data through the IoT applications so that they can take an informed decisions. And it is not a single entity. It is an interdisciplinary impact. Basically, you have engineering division comes into activity, you have environmental division comes into activity, you have microbiological activity department comes into activity, you have pesticide and entomological department. There are so many departments will come into aspect. So it is an interdisciplinary and a cross-disciplinary impact. So this IoTs will help you in taking further. So to conclude my topic, basically we are at a traditional farming. Getting to precision agriculture farming, we have to install these sensors to use this for understanding what's happening on the ground. Once the data is transmitted back and then data is analyzed, once the data analysis gives me the impact of whatever is happening, so that what needs to be done and how, because based upon the historical data, it will give me something, the information will tell me, compared to last year, am I doing better? Compared to last year, am I worst? Or what is happening which didn't happen in the last year? And what happens if some natural calamity is being existing in this year? What needs to be done? So I'll get an entire warning signals and also the suggestion and practices that needs to take in, wherein the entire data is driving the entire agriculture, when we call it as precision agriculture. The end of the day, the aspect is basically grow food which is smarter, safer, and more sustainable, wherein we are increasing the revenue and visibility. Simultaneously, we are reducing the cost as well as the risk for the farmer. Okay. Thank you so much. And I would like to take any questions if there are. And I hope this was, I hope somebody has understood. I was not quick enough.
Thank you so much, sir. I think so many of us have understood it, and because there are a lot of questions waiting for you. If the participants want to ask their question, they can please ask your question. Mohini Sharma, you raised your hand. Please ask your question. And if not, then I will be reading the question in the chat box. So a very wonderful presentation, sir.
Thank you, ma'am.
To conclude that, I will say that science is simply a common sense at its best, which Thomas Hurdley said. And innovation is the calling card of the future, as per Anna issue. So, the participants, please ask your question. Mohini Sharma, you raised your hand. Please ask your question. If not, then one question is there, sir. That are IoT farming tools equally useful for small and large farmers? By Santoshi Chakrabarti, ma'am.
To be honest, yes. But the problem is the initial investment cost is a little higher for now. But there are small gadgets which could give you a simple thing. Basically, if you have a weather data sensing, that will give you a lot of aspects, and most of the things. For example, if I am using IPM practices, if I want to understand what is a disease, if I take a picture, I get all the data of whatever the crop it is and what are the problems. So if I could be able to figure out, rather than going and then asking somebody what to spray, now you know what to spray at your end. So now you can go and ask, I want a particular chlorpyrifos of 10 EC, and this is what the volume that I want, because I want to spray only this particular end. So now you are at the end where you are able to ask the trader or any of the market person to give you what you need. And for the weather data, as I said, the IMD gives you certain data, so that can be accessible. Because most of the farmers nowadays have certain internet facilities. They have all the chats of different groups. If at all, if I am unable to access my information, there can be some FPOs nearby who can actually get the information and then provide it in the group on a daily basis, so that it will be helpful for a lot of farmers to understand. So if at all I am from certain area, if I will be able to tell them that this is going to be the problem, this is going to be the situation, and then all the people who are in this particular area have to take a note and then understand that they shouldn't spray for next 3 days. That could be helpful. But if I want to set up a weather station at my end, it will be a little expensive in the start.
The second question is by Dr. Rupa Verma. IoT could be successful in hydroponics or aquaponics?
Yes, absolutely yes. Because whenever we are using IoT devices, especially your pH is being tracked, your EC is being tracked, your light sensors are being tracked, you know exactly what is your PAR radiation, you know exactly what is your ambient temperature, you know what is the relative humidity, because everything is a weather based. You know the actual wind speed also, so that you are actually maintaining the temperature. It could be a fan pad system or it could be any other system. So it will actually encourage the grower, it could be a farmer or anybody, to understand what actually is an ambient situation. For example, if I am in a room, if I'm closely, if all my doors and windows are closed, I can stay comfortable for maybe about 15 minutes or 20 minutes. After that, I start perspiring. So basically, the temperature of the room is increased, the carbon dioxide levels in the room has increased, and the relative humidity has increased. There is a lot of things that is making me suffocated. Same thing is with the plants as well. So in hydroponics and also on the vertical farming, this is what the thing that is new, because we are doing it in soilless culture. So we have to be very, very cautious on what we are using and how we are using it. So any small mistake will lead to a lot of damage, because it is more expensive compared to the soil, because soil actually gives everything for free. It will give you a free anchorage, it will give you free nutrients, if there is a lot of rain, it will actually drain all the things, so that it is safe for you. But if you are working with a nutrient thing, if there is a power supply lag, automatically your circulatory system goes off, and then automatically the nutrient status is not be able to reach to the plant. So in this particular case, all these systems have to be there, which will help the hydroponics units as well.
Another question is, sir, that what challenges might arise when using IoT for crop monitoring in small farms with limited resources?
Yeah, excellent question. So the challenges basically is depending upon the type of data that you are accruing. For example, if I want to take everyday data, it becomes very, very expensive, because it's more of a satellite based imagery. So if it's an app, basically if I'm taking data for every 1 week, I'm still a little good. But thing is, if I have to take some application at the farm level, if my precision agriculture, basically if I'm doing some sort of an application, if my acreage is only 1 acre, if I'm doing on a crop, it's only few plants are there. Let's assume there are only 10% of it's under red, and then more than 90% is on green. Then I'll be able to go there and then do only on this 10% of the area, which actually increases my chances of what you call economy. So I'll be able to reduce a lot of resources, and I'll be able to precisely apply. But the amount of information that you draw and then apply it at the end is going to be something very crucial. So if I am at a larger area, the amount of economics will work out for me, because larger area, if I have 20% of the area which has to be sprayed, and then I'm taking out 80% of the area, it is actually doing a lot of good on me, because my resources are all limited. Basically, the people who are spraying is reduced, the time is reduced, the water is reduced, the fuel is reduced, and also the chemical is reduced. If I'm using it for a smaller acreage, the benefit is there, but it will be very limited. I don't know if I have answered your question.
So one more question is there. What eco-friendly methods can be used to protect mango blossoms from insect laying to avoid fruit damage later in the ripening stage? These problems happens mainly during rainy seasons in our area. Srilata Nair ma'am has asked this question, sir.
Can you come again, please, madam? I have missed the question.
What eco-friendly methods can be used to protect mango blossoms from insect laying to avoid fruit damage later in ripening stage And these problems happens mainly during rainy season in our area. Srilata Nair ma'am has asked this question.
Thank you, Srilataji. The question is really wonderful. The answer for your question is basically we have one company called as ATGC, which actually does a lot of pheromone mimics. So you have to put it on, you have to just have to put it there, and automatically we have been doing pheromones traps, we have been doing light traps, but this is a certain solution that you need to just apply it on the bark, and automatically there's a lot of insects, especially on the sucking pest. Fruit fly is the biggest concern. Tephritic fruit flies are the biggest concern, especially in mango. So these are they flock in, and then they are killed, because this solution is either as a tablet it comes in, it comes as a paste, and it can be put in any of these things, and then automatically there's a chemical which is added. The pesticide is added in. Like what we do in the previous stages is basically we used to take bottles, we used to put in water, we used to use 7 as a chemical, and then we used to use methyl eugenol, wherein these flies will come and drop in, because it is basically it is an attractant or a pheromone. But now it has gone down to, rather than putting all those bottles and everything, you just have to just take a small paste and then just have to apply it on the bark. This has a very beautiful effect, and I'll give you a lead for all the company if you have. It is ATGC. If you look at the company, it is based out of Hyderabad, and they're doing a wonderful job in this.
Thank you, sir. We have many problems with a similar case. We used to get spoiled thousands of mangoes every year. So that would be a very thankful this one suggestion that you have given. Thanks a lot.
Apurva, one more question, sir. Apurva Verma asked, what are the sources to download data set on agriculture on Indian subterranean for research purpose?
So we have government sites also are there, wherein you can draw things on the IMD is one of the weather data. We can go from the ICR is also providing certain data. You have NABARD, which provides the market data. There's so many, the APEDA also provides export data. So we have multiple departments, agriculture, APC marketing section is really, really wonderful data. You have data from last 25 years. They keep a long track of record for all the things. And the Department of Agriculture, especially the marketing department and Department of Agriculture on the national level is also a beautiful thing. And on the ENAM also has some data from the last 5 years also, wherein you can put in data which could be utilized for the research purposes as well. But I will also dig in some of these and then provide you the data. I'll provide to Shama madam and also Rupali madam so that you can use it.
Okay, thank you, sir. One more question, sir. Dr. Deepti Alex has asked that how challenging is to equip and educate common farmers on this smart farming. Can you elaborate more on IoT packages?
So this is the most tough and challenging thing that I see from the IoT perspective. Technology is very easy to, I mean, I'm not saying it is easy, but compared to the thing it is very easy, because it's a mindset that has to change, because people always, even if I have to change comes gradually. It's not like a transition from left to right straight away. So the farmers, they see to believe it. So it's not like if I tell them and then they start acting it. So you have to make sure that you actually incorporate something in some of the farm. You show them what is the thing, which is, we have demonstration farms, we have specialized farms for different field companies. So once they do it, automatically when they see the difference on the perspective of how the things happen, and then it is all from there. So some farmer, a progressive farmer comes in and he say, nothing is being recharged, you utilize this, you see it, and it will be a what you call an eye-opener for a lot of farmers around who will be able to join the program. And that is on the farmer scale. From the government scale, we have different agencies which work on. Extension Education Institute is one beautiful organization which is doing things. Manage is one organization which is actually doing a lot of programs. State Agriculture Universities also has their extension departments. Department of Agriculture, especially on the agriculture departments, also have specific personnel on extension. They also have local grip. So they know exactly which farmer to track down, and then which farmer, if I tell this farmer, he will be able to take a leadership role, and then he will be able to guide somebody. Because if I go there and if I tell them, you do this, there are so many hurdles, especially it could be based on caste, based on religion, based on region, based upon the party affiliations, based upon the what do you call economic sections. There are so many things. We cannot track down each and every session. So from an academic standpoint, the organizations will come forward. There are several FPOs which will be helpful. There are several NGOs, but the bottom line is transition will happen eventually. So even if we are able to transform 5 or 10 from a village in a given year, we have done a wonderful job. But once when we started from a small phone to a smartphone, there has been a transition, and now you see a transitional change. And with the internet coming from, not very many people used to use internet in rural areas. With inclusion of Reliance Jio, the data sets has been offered at a very, very minimal cost or at a nominal price. People started using it. Now they know the importance of data. So that is how the transition will happen. The same is with the UPI system, the wonderful UPI system. We never used to think that it is going to be the game changer, but now entire thing, even for 1 rupee of a transaction, 10 rupees of a transaction, people are doing it. The things will come eventually, but the value addition is not being appropriately told to the farmer yet, because they are seeing only on the crop production, but they are not seeing in from the perspective of economics, perspective of their market reach, perspective of their customer acquisition. So once you see them and once you show them, this is how you reach the farmer, this is how you have to do the quality, this is how you do the post-harvest technology, this is how you package it, this is how you brand it, this is how you get the revenue. If you are doing it for 1 rupee margin, you will get for 10 rupees. So if you have a tomato, you sell it for tomato at 5 rupees a kg, you can sell the same tomato dried, you can sell it for 50 rupees a kg. Or if you do a powder, you will sell it for 200 rupees a kg. If you are doing ketchup, you will do it for a different reason. If you take the seed out and then you sell it for a seed, it will be a different reason. If you're doing it a puree, it's a different thing. If you're doing a diced tomato, it's a different. So basically, on how you have to do, the farmer will be easily be able to convince. We can convince a farmer, but there has to be a logic and there has to be somebody who he can trust. That trust comes only the person who I believe in. So that belief comes from a progressive farmer or a person or an extension agent who is really, really visible to me on a daily basis or a monthly basis.
One more question is from Northeast, sir. Dr. Tamanna Bhuyan, USTM Meghalaya University has asked that what kind of IoT is applicable for the hilly terrain areas of Northeast India, including Assam and Meghalaya?
Wonderful question, madam. We have been doing it in Nilgiris. We are all in the terrains of
That's why I have taken this question, sir.
completely 25 to 30 degree slopes. So the biggest concern is basically the gradient is the biggest concern, because on the top, the soil, whenever it rains, whenever there is a huge amount of wind, there is an erosion. So it removes the soil, and then there is completely, you have a nutritional imbalance from the top to the bottom. First is that. Second is the operational thing, because whenever we have to do some operations, it's very easy for you to drive a tractor, drive a thing, and then do it straight away. So this one is again an operational hurdle. Third thing is basically on the different aspects, because when we, as I said in the earlier conversations, the slopes are either north side or east side or west side or south side. So you have a different kinds of climatic conditions. The sun angle is for the north side is different from day to the end of the day. The amount of sunlight that you get is different from the north side to the south side. So the growing degree days, what we call the growing degree days, is the amount of sunlight that is needed for the crop to, from the seeding to the harvest, that is needed for it to go to a vegetative to a reproductive stage, is called as growing degree days. That is again going to be a concern. So the extent of the life cycle will increase where there is limited amount of sunlight. So sunlight will be a factor for you to look at. Humidity will be a factor to look at. Then wind speed is another one that you look at. And then nutritional status is going to be the consideration for you have to look at. These are the 4 different parameters that we normally look at from the IoT perspective. And apart from this, again, there is one more thing called as leaf wetness, because leaf wetness will also be a factor, because you have a lot of diseases and also pests that will come in. Again, for different seasonal aspects, but that is also one area that you will be something to look at.
One last question, sir, that how AI helped in to resolve the issue of degraded forests
Okay. So when I say IoT, IoT individually cannot do anything. So we have to integrate IoT with remote sensing, with AI, with ML, with big data and everything, because it is a combined thing. So it is like a plate of thali. It's like thali. You can't have a rice at one. You have to have a curry, you have to have sambar, you have to have other things also to have a palatability thing. So the same thing with when you are talking about the forest degradations, the first thing is based upon the AI. I'll be able to sense how the reflectance patterns will tell me from the GIS aspect where the vacancies are, what is the amount of losses that I have. Now, looking at that, as I said, the vacancy analysis can be taken, the afforestation can be done. The first thing is seed ball program can be associated with FPOs and other areas looking at the forest. Second thing is understanding the nutritional dynamics over there. And second thing is what is the actual problem? We will be able to figure out actually what is the problem that we are looking at, because is it some sort of a afforestation being happening from the human interference, or from trampling of something else, or is some natural calamity which is actually harboring the thing. So if we understand the problem, we will be able to curtail it better. So once we understand those problems, we will be able to tackle it through the GIS applications, looking at the satellite imagery where the problem is, and then we go and then check what is happening and then we use other aspects to understand and coordinate different departments to work around it. I don't know if I have answered your question rightly, but this is the way of approach I would like to take.
So one more question from Chhattisgarh, that what is the acceptance rate of IoT in farming in India? From Dr. V. Shanti ma'am, St. Thomas College, Bhilai. Okay.
So this was my last slide looking at it. It is about, I don't know if I have put it there. It is about 13% for the medium farmers. I'll just open up this slide. I don't know, I have to share it, but I'll look at the, yeah. So it is almost about 28% for the high end, basically the anything above 10 hectares, because it could be a corporate, it could be a cooperative farming, or it could be a farmer who is really progressive. It's almost about 28%. The biggest concern with this is basically the problem of adoption has not gone up because the existing systems are already there. So the integrations of all these different platforms into their existing systems is a concern. For the middle thing, basically from 2 acres to 2 hectares to 10 hectares, the problem is the high cost of installation or the infrastructure is the consideration, and also on the aspect of utilization of that for the second level, basically on the higher cost and also on the training that is happening, because there is lack of training and also on the maintenance aspect. Coming to the lower farms, especially the less than 2 hectares of land, the ratio is only 3%. The adoption is only 3% as of today, because of, as I said, the costing, and second thing is the lack of awareness, because they are not really connected to the internet and also onto the different kinds of upgraded technology, because their product is such a low that they don't have the bargaining power. So if I have making only 5 tons, I can't take that 5 tons to a market and then sell it. So why? Because there's a lot of cost involved. So what I'll do is I'll sell it at the local market or somebody who is actually bulking it up, and then I'll say, okay, I got 20 rupees extra for my kg, I'm fine with it. So their adoption is because lack of awareness, and also they don't have that amount of things. Basically, when they pool together, let's have about 50 farmers or 20 farmers around them, they pool together, that is wonderful, and then they can adapt this. So that actually transforms themselves into a second stage.
Sir, my question is that your AgriPortal app monthly charges are what?
So we haven't done for the farmers. We haven't charging anything. I think it's about 80 rupees per month is the basic charge. But we haven't released. We have some of the farmers who are doing it on a pilot basis. We are coming up next year, but we are doing for the entire corporates. Harrison's Malayalam, we are doing it for AVTs, we are doing for Tatas, we are doing it for Adani Wilmar. So all of companies, we are doing for farmers who are on the higher scale, basically 500 acres and above, because we are actually we are doing it from last 6 years. But next year we are actually coming up to the local farmer, and we have already started with a few farmers on a trial basis from 5 acres all the way to 30 acres. Okay. So we are in the process. With this year, we will be able to figure out what actually goes in and how we have to operationalize, how we have to do it efficiently so that it is not a burden for the farmer, and it is what we call, it is our responsibility to reach out to the lowest farmer so that we can do a small change from their perspective so that it could be helpful for them, and definitely it could be the helpful thing for the nation itself.
Can we do this for our farmers at Chhattisgarh, sir?
Absolutely. We have been doing it.
An app and do
Our agri-portal things are being done in Japan. We have been taken up in Brazil. We have been in Kenya right now. We are doing operations at a very, very low level farmers. We have sent few weather stations there, and we are in Assam right now. We have started Assam, and then in the Nilgiris we are there. So we have introduced in different cropping systems also, but we are predominantly in coffee, tea, and rubber per se, but predominantly into tea. We have stronghold in tea. But we have done our research in grapes, we have done our research in sugarcane, we have done it in maize, we have done it in cotton. All the data work is done, all the things are done, but we are stepping into second stage because we started as a small startup as a robotics, and we have entered into AI/ML, and then we are reaching there. Maybe by next year, 2026, we'll be there, and then take all the help of all the faculty out here, the researchers out here, to put in a word, and also the students, and then the eminent researchers of, I mean the prospective researchers that are going to come in to take it forward and then help around for the building of the entire community itself as an agrarian community. We'll take it and then we'll do the transparent way so that the entire nation develops and we reach to the point where doubling the farmers' income of Prime Minister's initiative will be really be achieved.
Thank you so much, sir, for your wonderful presentation today. And I think so there are not any questions. If someone have any question, you can ask them. And
if we are unable to take the questions today, if somebody has questions,
yeah, I will share your.
If I have listed my number there,
yes, I will share your number.
Share the contact and also LinkedIn profile as well.
Also have it. And you had explained how just a smartwatch constantly monitors human health parameters. Smart sensors, drones, GIS, and remote sensing technologies can provide real-time insights into soil, crop, and resource management. You highlighted the applications of IoT across the entire agricultural cycle, from soil testing and seed sowing to crop growth, nutrient and pest management, irrigation, and healthy monitoring. Your emphasis on farm-to-fork traceability, mobile marketplaces, and data-driven supply chains was particularly valuable, showcasing how IoT ensures not only transparency and quality, but also empowers farmers to directly connect with consumers. Your lecture has clearly demonstrated that IoT adoption can help farmers achieve significant savings in time, resources, and costs, while simultaneously improving productivity and crop quality. As Edward Teller rightly said, the science of today is the technology of tomorrow. Your lecture has exemplified this thought by demonstrating how IoT can be the bridge between scientific innovation and tomorrow's agricultural practices. This session has indeed been an inspiring experience for all the participants, bridging the gap between technology and agriculture, and we are deeply thankful for your time, insights, and guidance. Thank you so much, sir, for inspiring us about the view agricultural through the lens of modern technology. We are deeply thankful for your valuable time, your expertise, and the clarity with which you shared your vision. It has indeed been a privilege to learn from you. And thanks to Mrs. Sujata Verma ma'am, CTO, Argus Embedded System, Hyderabad, who introduced you to us. Thank you so much, sir.
Thank you. Thank you to the Swarupanand Saraswati Mahavidyalaya and also the ICT and also my fellow researchers out here, my fellow faculty members out here. Thank you for being here to hear my lecture. And also, I would like to request if there is any possibility in sort of answering your questions, please shoot me an email or madam will give me my email address.
Mail ID and your number also, sir, to everyone. And last is the the Thanksgiving process is waiting. Rupali ma'am, please.
Yes, ma'am. Yes, ma'am. With this, we conclude day 3 of our FDP. On behalf of the organizing team, I, Rupali Kharche, sincerely thank both of our esteemed speakers for their valuable sessions. Our coordinator, Dr. Shama Ebek, for her constant support, and all participants for their active engagement. Now I formally propose the vote of thanks. Miss Yogita Lokhande, I would like to invite Miss Yogita Lokhande to kindly deliver it.
Thank you so much, ma'am. As we conclude day 3 of AICTE Technological Innovation in Agrotech and Food Processing, it is my proud privilege to extend the vote of thanks on behalf of Swami Shri Swarupanand Saraswati Mahavidyalaya. We are deeply grateful to our esteemed experts for today's highly insightful sessions. Our heartfelt thanks to Dr. Bhavesh Kumar H. Joshi sir for his enlightening session on smart packaging systems, his detailed insights on innovation, active packaging technologies, indicators, and use of biosensor and chemical sensors, and quality assurance opened new avenues of thoughts for all the participants. Thank you, sir. We are equally thankful to Dr. Satish Reddy Ambati sir for his engaging session on IoT's application in precision agriculture. His expertise on the integration of technology with farming practices, use of soil sensors, weather prediction, crop health monitoring, pest and disease management by disease detection apps, this real-time monitoring and data-driven solutions provided a futuristic outlook for sustainable agriculture. Thank you so much, sir. We remained indebted to our patrons whose unwavering guidance and constant encouragement continue to inspire and strengthen such academic endeavors. I would also like to acknowledge and gratitude the visionary leadership of our principal, Dr. Hansa Shukla Ma'am, whose constant encouragement has been the driving force behind the success of this FDP. A word of appreciation is also due to the faculty coordinators, Dr. Shama A. Beg Ma'am, and co-coordinator, Mrs. Rupali Kharche Ma'am, and whole organizing committee whose meticulous planning and teamwork ensured that today's session was conducted smoothly. And finally, and a special thank to all the participants whose curiosity, active interaction, and thoughtful reflections truly made this session more vibrant and meaningful. Thank you so much to all. Before we close, I kindly remind everyone to fill out the feedback form as it is also served as attendance and to join tomorrow's session on time for yet another enriching day of learning. Thank you so much.
Thank you so much, sir. It was nice hearing your lecture, sir. Thank you so very much, sir. We will be in contact with you for further innovations which we want to have at our place, Chhattisgarh.
Thank you.
Thank you so much. Thank you, sir. Good night to everyone.